Quantitative aptitude is one subject students get very scared in CSEET. CSEET is definitely an entrance test to make sure that you're ready for CS executive. Then why do we have mathematics, sir? Why should we study maths is a common question. Please remember, this is not really maths. This is basically basic arithmetic. Basic arithmetic is required no matter which field you are in. And as a company secretary, we do a lot of work relating to taxation, relating to accountancy, financial management. So you should know basic arithmetic. So this subject is something which you have to be very good, not only to pass CSEET, but later also it is useful. And remember, it is very easy compared to what you are thinking. And to make it easy for you, we have Vishwas sir from Excel Academy, who is giving you the complete classes, and we are putting it here on YouTube completely for free. So you'll get the complete syllabus of quantitative aptitude for CSEET. You just watch this video in full, you will be ready for CSEET exam. And don't worry, in executive and professional, we don't have maths or anything relating to that. Yes, you have arithmetic, you should know addition, subtraction, division, that is basic things, and some logical thinking relating to math is what you need. So let us go into this video and understand it properly. And remember, if you want some practice tests for CSEET, if you want any more help, you can WhatsApp us on 973-973-3400, or very simply just go to the description box. You'll get a link, and in that link you can click. You can also go to our website excelacademy.com, EKCEL academy.com, and there you will get the CSEET course for free. This YouTube video is free, plus in the course you get notes, you get practice quiz, you get a mock exam, all of that is completely free. Don't miss this. Now let us go into Vishwas sir's class, quantitative aptitude. Please watch the full video, you will be ready for exam.
Hello students, I am Vishwas, and as part of Excel Academy's CSEET classes, we will be now looking into quantitative aptitude. As you can see on the screen, quantitative aptitude is part B of current affairs and other associated topics of CSEET syllabus. This is something which the institute introduced only with this attempt. So until now we didn't have this quantitative aptitude as part of the syllabus, and this is there only for 20 marks right now. Of course, we still have logical reasoning as part of the syllabus, where some of the topics actually overlap. Now, when you think of quantitative aptitude, we have only two chapters, as can be seen on the screen. One is chapter 6 or lesson 6, which is the number system, and 7, fundamental arithmetical operations. Now, number systems is something which you would be already familiar with. This is mostly theoretical in nature. And fundamental arithmetical operations is also something which you would have already done. Meaning, this is not something which you will be learning afresh. These are the topics which you are already familiar with. I think this is the only section in the entire syllabus where you would find it easy to understand, because this is not something new to you. For example, when you think of fundamental arithmetical operations, what do we think of? We know that we have addition, subtraction, multiplication and division. And that entire chapter is based on these 4 operations only. That's all. And number systems is mostly theoretical. As I said earlier, it's all about what is whole number, what is natural number, what is a rational number, irrational number, integer, decimals, fractions, etc. Apart from these two, we don't have anything else in the quantitative aptitude section. You can think of these 20 marks as pure lottery. Meaning, there is every chance of you scoring 20 out of 20 in this section. No matter how difficult or tough or easy or whatever it is, I don't think scoring 20 should be a Herculean task as far as quantitative aptitude is concerned. Before we proceed with the actual content of the syllabus, let us quickly go through the overview of the syllabus. This is part 4, quantitative aptitude, and the objective as given by the institute is to test the basic understanding of QA and nothing else. That means if you know the basics of this, then you don't have to worry much about this. So they have given us what are the subtopics contained in each of these lessons. For example, in case of lesson number 6, which is the number systems, we have the subtopics of computation of a whole number, decimal and fractions, relationship between numbers, as I said, theory. Then comes chapter 7, which is fundamental arithmetical operations, wherein we have percentages, ratio and proportions, square roots, averages, interest, simple and compound interest, profit and loss. As far as the last 2, 3, 4 topics, they haven't given much in the material. So I'm not so sure if the institute will ask too many questions regarding those, but in any case, we'll be solving problems related to those as well. Okay, so now that we have had a brief overview of the subject, or rather the part of the subject, and also had a look at the subtopics of the syllabus, now we can directly get into the lesson itself. Now, if you look at the text there in the first part of the QA, what do they say? A number system is an arrangement of expressing the numbers in written form. Digits and symbols in a consistent manner are used in a number system. All the numbers are represented in the arithmetic and algebraic structure. The number system, among other things, facilitates addition, subtraction, multiplication, and division. This, you can think of this as an introduction or gist of what all the number system does. If we have to go into the details, it would be like this. First of all, they talk about the arrangement of expressing numbers. A number system is essentially, what is it? It's essentially a method, or you can say an arrangement for representing numbers in the written form. So we have an order here, wherein it's a predefined order. It's not something which we found out just now. It's been in use since a long time, and it provides a structured way to express numerical quantities. We cannot express quality in terms of numbers, whereas we can express quantity in terms of numbers. For example, if you have a, let's say you had a very good dosa somewhere and you liked it, you can't express this in numbers. Whereas if someone asks you, how much did you pay for the dosa or dosa, then you will obviously be able to answer that because it is expressed in terms of numbers, which are in order. So that is what they are essentially trying to tell us. And digits and symbols in a consistent manner, they say. So what exactly they are referring to? In a number system, there are specific digits and symbols that are used consistently. That means when a particular digit is used, we know what exactly it is referring to. Its meaning or its whatever it quantifies, it won't change. These elements will have predefined values and meanings, ensuring what? The uniformity in representation. So that is what we mean by digits and symbols in a consistent manner. Then they also talk about the arithmetic and algebraic structure. See, what you have to understand is number system is not an isolated entity. They are organized within a framework that supports both the arithmetic as well as the algebraic structure, or rather the arithmetic and algebraic operations. This means what? That number system is designed in such a way so as to handle the basic mathematical operations like addition, subtraction, multiplication, division. So it facilitates all these operations. Whether you are adding, subtracting, multiplying or dividing, the structure of the number system allows you for systematic and consistent computation. It will never deviate. No matter who calculates, the answer will still be the same, because we are working based on set or predefined system. Okay, so that was the introduction. Now let us look at the types of numbers. We have different types of numbers here. Let us see what each of these actually mean. Now let's start with the first type of numbers, which is the natural numbers. The name itself actually tells us what exactly they refer to. See, natural numbers by definition are a set of positive numbers that start from 1 and it continues indefinitely. There is no end to it. Only the starting point is known and not the end point. So you can think of any number. If you add 1 to that, the natural number will extend, obviously. That's why we say it goes on and on and on indefinitely. But it starts from 1. Now, why are they referred to as natural numbers? See, if someone asks you, for example, let's say, count the number of oranges in the basket, then what would you do? I would be like, okay, 1, 2, 3, 4, 5, 6, 7, 8. Count the number of students in a class. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So where do we start it from? We start it from 1. These are all integers, positive integers, which starts with the number 1. So we don't say 0, 1, 2, 3. We say only 1, 2, 3, 4. So that's why it's a natural process of counting. That's why we refer to as natural numbers. And it's something which we use in everyday life also, no? So for example, they're used for counting items, telling time, expressing quantities, and various other real life situations which you can think of. So but one thing which you have to remember here is, one of the properties of natural number is there is no greatest natural number. Any number which you can think of, if you add 1 to it, as I said, that will be the next higher natural number, no? So therefore the greatest number you can think of would be n plus 1. Whatever that n is, plus 1 will again continue the natural number. So they have given few examples like what are the basic operations which we can do with natural numbers. 4 plus 2, of course, these are all addition. We can do any operation with respect to natural numbers. Addition, subtraction, multiplication, everything works. But one thing which we have to be sure of is it should be a positive integer. For example, let's take this example only. 2 minus 6. 6 minus 2 is obviously a natural number, 4, positive integer. Whereas if I reverse this, then it won't result in a natural number, because then I would be looking at 2 minus 6, which is nothing but minus 4. Minus 4 is not a natural number. It's not a positive integer. We'll come to integer as well in a second. Okay, so 4 plus 2 of course is a natural number. 6 plus 21, yes. 22 minus 6, of course we know that. Multiplication also works. 4 into 3, 12, and 12 into 3, 36. So now they are talking about the fundamental operations with respect to natural numbers. We can do addition, subtraction, multiplication, and division. For example, 12 divided by 6, obviously it will result in a natural number, whereas not all division, not all subtraction will lead to natural numbers. For example, 6 divided by 4 is not a natural number because it results in a fraction, or in other words, decimal. When that is the case, we are going beyond the definition of natural number. It has to be something which can be expressed in multiples of 1. This cannot be expressed like that. So therefore that would not be a natural number. So that means what? If there are a set of natural numbers, you can perform the operation of addition, you can perform the operation of multiplication, which will invariably result in another natural number. Whereas if you have a set of natural numbers and if you perform the function of subtraction and division, it need not always result in a natural number. Sometimes it will not result in a natural number. Okay, so that is the thing which they are mentioning here. Okay, so the next is the whole numbers. Okay, let's elaborate on the concept of whole numbers, particularly addressing the inclusion of 0 and their characteristics. So now when you think of natural numbers, we know it's all positive numbers starting from 1 and continuing indefinitely. However, when you subtract let's say a natural number from that number itself, the result is always 0. For example, let's say 10 minus 10, both are natural numbers, and when I subtract this number from this number or whatever, so the answer would obviously be 0. So now there was this confusion. No, 0 is not a natural number, but if we don't include 0, then it won't be complete also. So to address this challenge, what they thought was, let us do one thing, let us keep natural numbers as it is and instead form a new category called the whole numbers, wherein we will include the 0. So that means what? Apart from this inclusion of 0, whole numbers are nothing but the natural numbers only. Okay, so this extension of 0 resulted in a new system called whole numbers. So that means what? Whole numbers includes all the natural numbers along with 0, and natural numbers are denoted by n, whereas the whole numbers are denoted by w. That's the way it is denoted. And one more thing, whatever applies to natural numbers will apply to whole numbers as well. For example, we cannot include fractions, there cannot be negative numbers, there cannot be decimals. All these rules which are applicable there will also be applicable here. Again, one more thing which we saw there was there is no such thing as greatest natural number. Same thing applies here too. There is no such thing as greatest whole number. Any whole number you can think of, add 1 to it and you will get the next greatest whole number. So once again, for what do we use whole numbers? Same thing as we use natural numbers, counting, measuring and various mathematical operations. So that is the thing with respect to natural numbers. And of course, division by 0 is not defined, they say. That means think of any natural numbers, let's say 5. 5 divided by 0 is not defined at all, because there is no way any number can be divided by 0. Whereas 0 divided by 5 is easy to answer, because 5 into 0 is anyway 0. So therefore 0 divided by 5 is 0 itself. Whereas the vice versa is not true. So if at all you get a question wherein they say division by 0 of a natural number or a whole number, then your answer should be not defined, not 0. And again, they have given a diagram here wherein you can just see the whole numbers being represented in a line starting from 0 and proceeding towards infinity. N plus 1, that would be the last natural number. Okay, of course these are not natural numbers. Minus, if there is any negative sign, they would not come under the natural numbers category. So that is the thing with respect to natural numbers. Let's do one thing, let's move on to the next topic, which is the integers. How did they come about integers? See, when we are working with one particular thing, or in this case natural numbers or whole numbers, or rather when we didn't have all these things, or when maths wasn't advanced as it is now, they probably realized that there is some limitation here, basic limitation with respect to natural numbers and whole numbers. In case of natural numbers or whole numbers, let me just say whole numbers because whole numbers anyway includes natural numbers. In the system of whole numbers, subtraction is not always straightforward. For example, if you try to subtract a larger number from a smaller number, for example 5 minus 7 or 6 minus 14, 18 minus 38, the result is not always defined with the existing number system. For example, let's say this and this. These are the examples which I considered right now. Now, what would be the result of that? 5 minus 7 minus 2. Where will you see this in the line of natural numbers? Because natural numbers or whole numbers, it starts only from 0. Same thing with 6 minus 14. So this is something which I cannot fit there. No? So that is the reason why they perhaps thought that we need something else which can extend the number system to handle these situations where subtraction is not possible with the natural or the whole numbers. They thought we need an extension of the existing number system. So as a result of that thought, we have something now known as integers. Negative numbers denoted with a minus sign, they were introduced to allow for these type of subtractions. Now, okay. Now that we know that 5 minus 7 is minus 2, it cannot be a natural number, it cannot be a whole number. Therefore, we introduce something known as integer, which also includes whole numbers, and along with that, it also provides for negative signs. So that's how integers were introduced. And also with respect to multiplication, whole numbers can be multiplied by negative integers such as, let's say, minus 1 or minus 2, and this will result obviously in negative integers. For example, 10 is a whole number. If I multiply by minus 1, which is a negative integer, the result will be minus 10. This is obviously not a whole number, this is not a natural number. So what is this? This is a negative integer. So that means what? Integers will include positive numbers, 0, as well as negative numbers. Okay. So the set of integers is usually denoted like this, kind of Z symbol. So with respect to multiplication, we saw that even when you multiply by minus 1, you can still have that number, and that will be denoted by integer. And also with respect to subtraction also, now we can subtract a larger number from a smaller number, so that will also result in a integer. So this is how an integer can be represented in a line of numbers, where starting from this part it is the whole numbers, whereas all put together would be considered as integers, because integers includes everything. So again the same thing. So various points they have mentioned, nothing great there. So the rest is what we have discussed so far. There are a few examples which are mentioned here, kind of an exercise, simple ones. Let's just look at this. First one, classify natural numbers, whole numbers and integers among the following. We have 15, 22, minus 6. The moment you see minus 6, minus 7, minus 13, whatever, you can easily identify that is not a whole number, that is not a natural number. It can only be an integer, because only integers will include the negative numbers. So now let us start with the natural numbers. So natural numbers is easy to identify, because we know for a fact that it is nothing but a positive number excluding the 0. So now if I have to zoom this, 12 natural number, 13 natural number, 7 is a natural number, 22 is a natural number, 15 is a natural number. So these are the only 5 natural numbers which we have in this set. So that is with respect to the natural numbers. Now whole numbers would be much more easier, because we have already defined the natural numbers, which are these. Now to that add just this 0 and you will be done with the whole numbers. And when it comes to the integers, whatever is included here, that is in whole numbers, will be included in integers as well. On top of that, we will also include the negative numbers. So which would be the negative ones, minus 6, minus 13, minus 12, minus 31. These would be added to the set of whole numbers which are already defined here, and then we will get the integers. So okay, they have surmised something. Let's see. All natural numbers are whole numbers. Of course, yes. And integers, natural numbers are whole numbers and also integers at the same time. But all integers need not be whole numbers. All integers need not be natural numbers. Okay. And all whole numbers are also integers, they say. That is also true. Simplify the following and indicate whether or not the outcome is an integer. Okay. 12 into 4 obviously is an integer, because 12 4 is 48. 7 by 3 is a fraction. Fractions are not part of the integers, so therefore we'll have to simply ignore this. This is not an integer. 18 by 3 fraction, 36 by 7. Okay, 18 by 3 we can still consider. So even though it is a fraction, it can be simplified, no? So 18 by 3, since the question itself is about simplification. So 6 would be the simplified form of 18 by 3, because 3 times 6 is 18. So this is an integer. 36 by 7, not possible, whereas if it was 35 by 7, it would be possible. The simplified form of that would be 5, and 5 would be an integer. Then we have 14 into 2, obviously an integer. Both are natural numbers. When two natural numbers get multiplied, it will result in a natural number only. Okay, and of course any natural number is also an integer. 18 by 36 is not possible, whereas 36 by 18 would be an integer. 18 by 36 will simply result in a fraction, decimal, whatnot, whereas 36 by 18 would have resulted in 2, which would be a natural number. And 13 multiplied by minus 3 is also a natural number, because we know any whole number which is multiplied by integer will result in an integer itself. So therefore 3 is an integer, minus 3, and that is multiplied by 13. So 13 into 3 is 39, but in this case it is a minus 39, which is also part of the integer. So that's how we decide. Let's move on. Using number line, add the following integers. Again, you don't have to worry about these type of questions in the exam. You will obviously not get this. This is only for your understanding. So we have a number line starting from minus 7 ending with 9. So what do they say? Add minus 5 to 9. That means whatever is this is the 9. From that we have to remove 5. So when you do that, what you will be left would be nothing but 4. 9 plus minus 5. So minus into plus would be minus. 9 minus 5 would result in 4. For example, when you do that, how have they represented this? 1 2 3 4 5. Okay, what is left is 1 2 3 4, like that. I don't think it's proper representation, but anyway. Okay, let me just read whatever they have written here. At A represents 9. Okay, fine, on the number line. Going 5 units to the left of A. Okay, we reach point B. Okay, fine. 1, 2, 3, 4, 5, which represents 4. Okay, like that. Okay, nice, got it. So 1, 2, 3, 4, 5, and whatever is left would be 4. That way also we can actually identify the operation. Basic operation, subtraction, that is. Then what else? There is one more here, -3 and -7. So we have -3 here, and then we have -7 here. So when both are added, sorry, -7 starts from here. When both are added, you will get -10. Okay, point A represents -3, point B, or rather A to B, represents -7. When you add both, you will get this, that is from this point to this. So we know for a fact that -3 plus -7 is nothing but -10. So that is what we have here. Again, it's all elementary stuff, not required for you guys. Okay, so that finishes our topic of integers. Next is the rational numbers. Until now, we haven't entered the area of fractions. We have been looking at natural numbers, whole numbers, integers, but not the fraction. We have even got the negatives and that is integers. Now, what is this rational number? As I just now said, it's a number which can be expressed in the form of a fraction or the quotient of two integers, where the numerator is an integer, the denominator is also an integer, but there is one condition, which is the denominator should be a non-zero integer. In other words, it can be written in the form of, as seen in the screen, a by b. One more thing which I wanted to mention, I have deviated from the institute notes because I think that is slightly confusing with respect to the way the material is worded. They have directly copied from some other source material. They have given the links of the same as well. If you want, you can check the source material, but I don't think that is required either. Anyway, coming back to the point, a rational number can be expressed in the form of a by b. A divided by b, of course, where both a and b are integers, but b should be a non-zero integer. That's all. As long as that condition is fulfilled, then there is nothing much to do here. So let us look at the characteristics of this rational number. A rational number is essentially a ratio. Of course, it is expressed in the form of a fraction or quotient of two integers. The numerator and the denominator can be positive, negative, or 0. Of course, this or 0 applies only for the numerator part, not the denominator part. For example, 5 by 4 is a rational number. 3 by 4 is also a rational number. -3 by 4 is also a rational number. Okay, so this is also a rational number, but this is not a rational number. Denominator cannot be 0. It will be undefined then in that case. Form of a rational number, of course, we just now saw. Form is nothing but how it is expressed. It is expressed in this form. Examples, of course, these are common examples. 3 by 4, it is nothing but 0.75. Then -5 by 2, 0, 7 by 1. Some examples, there are few things which they have mentioned here. -5 divided by 2 is also a rational number. Yes, it is. 0 can be expressed as 0 by 1, which we saw. As I said, this is a rational number, whereas this is not a rational number. Okay. Integer can be expressed as a fraction with a denominator of 1. That means any number, for example 55. This can also be expressed in the form of a fraction when you just divide that by 1. So just put 1 as the denominator, then you will be getting a rational number. -2 divided by 3 is another rational number. Okay, there are various examples. You can just go on and on and on with respect to the examples. Moving on, the other characteristics. Terminating and repeating decimals. See, in case of fraction, decimals is something which is unavoidable. Decimals will be there. For example, we'll take this only. 1 divided by 4, 1 divided by 4, 0. Point, because 1 cannot be directly divided, so I will borrow one 0 here. 4 2s are 8, 2 is the remainder. Again, since I have already put the decimal here, I can put one more 0 here. So 4 5s are 20. So that means it's a terminating decimal. So that means we are done with the division of 1 by 4. we already have got the answer, 0.25. In some cases what happens, this will not be the case. For example, 1 divided by 3, 0 point, we'll get 0. 3 is a, sorry, 9. 1, again same thing. It will go on and on and on forever. We can just go on, it will never end. So that means what is it? Repeating decimal. Same thing is getting repeated or recurring. That is with respect to terminating and repeating decimals in rational numbers. Then since we are looking at terminating or repeating decimals, we can also have a look at the irrational numbers at the same time, because irrational numbers are not very different from the rational numbers, but here what happens, whatever is the result, you can't get in the form of a fraction. For example, root of 2 whatever is this, for let me just try to do this, 2 square root, I don't have the root function, yeah I have. See, look at this answer, 1.4142135623. It will go on, of course, the calci doesn't have so much space, but can you see if there is a pattern here? Is it repeating? Of course not. Is it terminating? Of course not. So this is referred to as an irrational number. Or you can even think of a pi, that is 22 by 7, 22 divided by 7. This will go on and on and on. For example, 3.14285714285. It will just not repeat, not terminate. So that is referred to as irrational number. Again, with respect to rational numbers, we can obviously do all these arithmetical operations like addition, subtraction, multiplication and division, and will of course result in another rational number. So that's all about the number system as such. We'll be looking at different problems, different aspects, computation of numbers in the next part. Okay, now let's move on to the next topic, which is the computation of whole number. Under that we have the first main heading, which is the predecessor and the successor. It's a very simple concept. Let's say you got your favorite number, right? Cool. Okay, now if you add 1 to it, you get what's called the successor. Picture this, you roll a dice, you get your lucky number 6. Now add 1 to it, bam, and you're looking at 7. That's the successor of 6. Same drill. If you're, let's say, vibing with 10 and add 1 and you're cruising with 11, that's nothing but the successor of 10. So successor is a very easy concept to understand, wherein to whatever number we have, we add just 1 and we get the successor of it. Therefore, when it comes to the whole numbers, there is no end to it. When it comes to the natural numbers, there is no end to it, because whichever highest natural number you can think of, when you add 1 to that, you will get the successor of that, which is also a natural or a whole number. We know that every natural number is a whole number, so that's there. Then when it comes to predecessor, it's nothing about the number before the main act. For example, let's say you are you throw a dice and you get 5, and the number which is before 5, or when you subtract 1 from 5, what is that you get? You get 4. That is nothing but the predecessor of 5. So it's just like the number that warmed up the stage before the headliner. That means the one which came before. So when you add 1 to your digits, you are in the successor town. Moving forward, subtract 1 and you are back in the predecessor land, reminiscing about the good old numbers that came before. So that's the math of the streets, my friend. Okay. Now that is about predecessor and successor. Let's look at the whole number. We have already, but as I said, there are repetitions here in the notes, because this is not exactly the original notes prepared by the institute. They have heavily borrowed from NCERT. That's why I said this is one such topic where you would be mostly revising even when you are studying for the first time, because it's not something which is new. So what we can understand from this is, each number possesses a distinct narrative characterized by its antecedent and subsequent counterparts. That is what we studied now. So wherein we have the successor and the predecessor. Okay. So now one thing which we have to understand here is, even though we took various examples like 5's predecessor was 4, 6 successor was 7, etc., etc., when it comes to 1, what is the predecessor of 1? See, earlier when we only thought of natural number, the predecessor of 1 was -1, because if you think of natural numbers, it will be 1, 2, 3, 4, 5, 6, like that. There is no predecessor to 1. Of course there is successor, which is 2. So then what did we do? We threw in 0 to make sure that 1 is not left alone, and it has 0 as its pre-party chill spot. So that is what it is. And in the next section we have what we have already seen, that is the whole numbers and natural numbers comparison. I don't think we need to get into this again, but let me just skim through this quickly. All positive integers including 0 are whole numbers. We already know this. Positive integers, be careful, because the whole numbers, as we just know, so it starts from 0. If it's natural number, it starts from 1. Real numbers are whole numbers, that also we have seen in the previous session. Whole numbers make up for all the nature's numbers, fine. All natural numbers except 0 begin with 1. All natural numbers, okay, they will have to start with 1, of course, yes. The smallest whole number is 0, because before that we have integers. It will not be considered as a whole number. Okay, natural numbers are regarded as whole numbers, although fractions, decimal and negative numbers are not. Of course, we have different terminologies for each of this. We have already seen that, so I won't get into the others because it's a repetition of the same thing. So once again we have the same whole number line, natural number line, repetition, so we can just strike this off. So now we are looking at different properties of whole number. So that is what we'll be looking at with respect to whole number, starting with addition property. This is a very simple rule which says adding 0 to any whole number is like a math superhero with no costume change. A math superhero with no costume change. That means nothing happens. Add 0 to 5. It still remains the same. You can think of 0 as the math ninja that leaves things unchanged. No matter which number it is, add 0 and the number remains the same. So that is the addition property. So then comes the closure property. So now imagine your numbers are all friends at a party. The closure property says if you add or multiply two friends, the result is always part of this squad. For example, there are 4 friends and 10 friends, bam, then we have 14 friends who are all part of the same party. Okay, and since we are talking about the party, let's think of it as a party of whole numbers. We have 4 as one whole number and 10 as another whole number. Okay, so now even when I multiply these two whole numbers, we are still in the same party of whole numbers, because we will get 40 as the resultant whole number. So no outsiders allowed here. That means when a whole number is multiplied with another whole number, the resultant figure will still be a whole number. So that is about the closure property. Then comes the associative property. In this case, picture this. Multiplication and addition are chill with how you group the numbers, meaning no matter how you group them, for example, whether it is 3 into 10 or 10 into 3, the resulting figure will still be 30, no? Right? Whether it is 3 into 10, which is 30, or 10 into 3, which is also 30. See, the grouping is reversed in this example, but still the last result is still 30. Okay, same goes for addition as well. 3 plus 5 or 5 plus 3, both will give us only 8. So math surely doesn't care about the order of the numbers when it comes to whole numbers. Then we have the multiplication property. This one is actually straightforward. Multiply any number by 1 and it's like looking in a mirror. You get the same number back. 8 into 1, it's 8, bro. But throw 0 in the mix and it's like, oh, it's a different story now. 0 into 7, it's 0. Because any number multiplied by 0 will be a 0 itself. Whereas 1, it's like looking into a mirror. So that's about the multiplication property, where we looked into what happens when it is multiplied by 1 and what happens when it is multiplied by 0. Then comes the division property. This division by 0, that is what we are looking into here, is like asking your math teacher for the answer to the meaning of life. What's the meaning of life? It's undefined. It's a mystery, right? So here also, if you divide, let's say 7, or in this case they are given 7, okay, so let's make it 17, doesn't really make any difference. 17 by 0, what is 17 by 0? The maths teacher will say, sorry, it's like life itself. We do not know what's the meaning of it. It's undefined, it's a mystery. No one can answer that one. Undefined territory. So the answer in this case would be not defined. Whereas the reverse is not the case. 0 by 17 is easy. It's 0 itself, because 17 multiplied by 0 is 0 itself. Whereas this, that is 17 by 0, is undefined. Then comes the distributive property. Imagine you have three numbers, A, B and C. It's like this distributive property is like a DJ at a math party. No matter how you mix and match, you'll still get the same number, same result. For example, A into, sorry about that, A into B plus C, okay, equals A into B plus A into C. So if this is confusing, let us take up numbers itself instead of alphabets. 1 into 2 plus 3. How much is this? 3 plus 2 is 5. 5 into 1 is 1. Is equal to 1 into 2 plus 1 into 3, which is also 5, because 2 into 1 is 2, 3 into 1 is 3, 3 plus 2 is 5. Think of any number instead of A, B, C here, or P, Q, R as the material has considered. You'll still get the same answer. This is referred to as distributive property. Then lastly, we have commutative property. In this case, imagine you have again A, B and C as friends. So here also we have the same thing. Even if you swap, let's say they are dance partners, the resulting figure will still be the same. So P plus Q, I'm just considering the same example here, is same as Q plus P. Okay, so if I have to take an example, 15 plus 16 equals 16 plus 15, same 31. Okay, so that is what we have in case, in commutative property. All these are very easy properties, and these are all obvious things which you already know. That's why I said this is more of a revision session. Okay, so that was all about the properties. In the next part, we'll look into the rounding of fractions. Before we move towards the sample questions on whole numbers, there is one small topic which is rounding of fractions. Let us quickly go through this and then proceed towards the sample questions. So now, with respect to rounding off, there are only two rules which you have to understand. See, the rules are very simple. One is a decimal which is less than 0.5. If the decimal part is less than 0.5, then you round off to the lower whole number. For instance, if the decimal is 6.3, now look at the decimal part. 0.3 is less than 0.5. Since 0.3 is less than 0.5, we will round off to the lower whole number. The lower whole number of 6.3 would be 6 itself. If it was instead 6.5 or above, meaning the decimal part, if it is 0.5 or above, that is greater than or equal to 0.5, then we round up to the next whole number. If it is less than 0.5, we round down. If it is equal to 0.5 and greater than 0.5, we round up to the next whole number. For example, 6.5 in this case becomes 7. Same thing with 3 also. Let me just add a page here, just give me a second. So now in this case 3.5, since it is equal to 0.5, it becomes 4, round up. 3.4 round down, which will be 3. So that is the whole funda behind the rounding off of decimals. Only thing is we have to look at the decimal part. Less than 0.5, round down. Equal to 0.5 and above, then round up. So if I have to look at few more examples, it would be like this, 9.2. So now the decimal part, only look at the decimal part. If it is 0.5, if it is less than 0.5, round down. So I will round it off to 9. If it is 0.5 or above, then I will round up, which will be 10. Yeah, we can think of a number of examples. Let's say 12.9 more than or equal to 0.5, so round up. 12.4 less than 0.5, so round down to 12. So in summary, what we can say is rounding off simplifies the decimal numbers by considering whether the decimal part is closer to the lower or the higher whole number. It's a practical way to express values in a more manageable form, especially in the real world scenarios where precision is not that critical. So that is the whole funda behind rounding off of the fractions. Okay, now let's look at the sample questions on the whole numbers. Let's look at the first one. The first one says a number in which 1/5 part is increased by 20 is equal to 1/10 part of the same number increased by 30. Find the number. Of course, we have the answer here, but let us try to find out how to arrive at the answer logically. So we do not know the number yet, so let that number be x. So now the first part of the question says 1/5 part of that number, if it is increased by 20, 1/5 part of that number will be calculated first, which will be increased by 20. That means we'll have to add 20, will be same as the same number, and considering 1/10 of that number and increasing that by 30. So this is the equation which we are looking at. X into 1 by 5 plus 20 equals x into 1 by 10 plus 30. So we do not know what is that x, what is that number. So let us try to identify that number. So if I have to write down in the form of equation whatever I wrote down earlier, 1 by 5x, since x into 1 by 5 is 1 by 5x, plus 20 equals 1 by 10x plus 30. So now what we can do is to simplify, we'll get rid of the fractions and consider only the whole numbers. So for that to happen, what we'll do is we'll multiply by the largest denominator here, which is 10. So what I will do here is 1 by 5x plus 20 into 10 equals 1 by 10x plus 30 into 10 again. So when I do this math, 5 ones are 5 twos are 2 into 1, 2x plus this will be 10 into 20, so that will be 200 equals, here also 10 gets cancelled, so it will be x plus 30 into 10, 300. This is the simplified form of the equation. We can of course further simplify here. So what I'll do is I'll just bring this to LHS and this I'll take to RHS. So 2x minus x will be 300 minus 200, so x will be 100. So the number in question in this case is 100. Now all that we need to do is verify. So once again let us go back to the question. A number in which 1/5 part, that is 100 into 1 by 5 plus 20 will be equal to 100 into 1 by 10 plus 30. So 5 20s is 100 plus 20 equals 40. So 10 into 10 tens are plus 30. So therefore 40 equals 40. LHS equals RHS. That solves the problem. Okay, now let us look at the next question. The product of two numbers is 150 and the sum of squares of numbers is 325. So we'll consider two numbers as a and b. So the product of two numbers, that is a into b is 150 and the sum of the squares, that is a square plus b square, is 325. Find the sum of both the numbers. They are not asking us what are those numbers, but instead they are asking us to find the sum of both the numbers. So now one thing which we can do here is, since they have asked us to find out the sum, let me just write it down. A plus b whole square. I will use this formula for the simple reason that we know the variables in the formula. For example, if I have to expand this formula, this will be a square plus 2ab plus b square. That is the expansion of a plus b whole square. So now in this case, what is that we know? We know a square plus b square. We know ab, that is 150. All that we have to do is multiply that ab by 2. So a plus b whole square, whole square will be a square plus b square, a square plus b square plus 2 into ab. If I have to simplify, I'll just use right here, there is no space there. So a plus b in our case is how much? What is it? A square plus b square, no? So that in our case is a plus b whole square equals a square plus b square, which is 325. Plus product we know is 150, but 2 into ab, so 2 into 150. So this will be 325 plus 300, which will be 625, which is a plus b whole square. But the problem here is they have not asked the sum of both the numbers square, but instead they have asked sum of both the numbers. That means this square should be removed. So if I have to remove that, what I can do is I will shift it to RHS. So when I shift the square to RHS, it becomes square root. So 625. So that will be 25. A plus b therefore equals 25. So that is the thing. Now let us look at the next question. This is a very easy question, nothing much is happening. Which is the largest 4-digit number divisible by 91, they say. So 9919, 9900, 9909. So we in fact don't need these choices at all, because all that we need is the number which is given, 91. First, do one thing. Think of the largest 4-digit number. The largest 4-digit number is anyway 9999. All that you need to do is divide this by 91. When you do this, you will actually get the answer. So 91 times 91 ones are 91. 9 minus 1 will be 8, and we can carry down only one number, that is 9 from here. But we are left with 89, which is actually less than 91, so we cannot divide. So I'll add on 0 here. So this will become 890. So now we know 91 into 10 is 910. So therefore 10 is not possible. So 9, the previous number we'll consider, which will be 9 ones are 9, 9 nines are 81. So in this case, how much are we left with? 10 minus 1, 9, 1, 8 minus 1, 7. So some fraction will come into picture. So basically the answer is 109 with some remainder. So what we need is to multiply 109 by 91. So this will be 109 itself. 9 nines are 81. 9 ones are 9. So 9199. So the largest 4-digit number which is actually divisible by 91 is 9919, which is option A. So that's how we arrive at the answer. Again, in the exam it will be difficult because you are not allowed to use calculator. So even without using calculator, as I solved here, you can still do it. But this is one of those problems which the institute, I don't know for what reason they ask such questions. So be it. Let's not worry too much about that. If the number is 61xx4 is divisible by 6, then what will be the value of x? That means 61,000 something. Okay, that something we do not know because that is x and x. Then what will be the value of x? Okay, this again is very difficult to solve straightforward without looking at the options. Options here are 4, 5, 6, 7. One way of solving this would be simply substitute all these one by one. For example, 61,444 divided by 6. Is it possible? Okay, so let us check this. 61 10 times. Okay, let me just use the other sheet here. 61 444. I'm just replacing x by 4 divided by 6. 61 tens is 60. 1 4 6 2s are 12. 2 4. I'm just carrying down here. So then 6 4s are 24. Nothing is left. Then I'll have to carry down 4, but 4 cannot be divided, so I'll have to use a decimal here. Something will 0 will be added. So 6 5s are 40. So obviously not working because it is not perfectly divisible by 6. We have to use a decimal here, so that is not working. Then 61 instead of 4, I will now replace it with something else, which will be 5. 61 10 times is 61, then 5 carried down, 6 2s are 12, then 3 carried down, so 3 remainder, then 5 again carried down, 6 5s are 30, 5 carried down, and 4, when I bring it down it is 54, and we know 6 9s is 54. So therefore that XX should be replaced by option B, which is 5, and then the number would be perfectly divisible by 6. Alright folks, let's talk about decimals and fractions. That's our next topic. Let's first talk about the fractions. So you know, fraction is just a fancy way of expressing a part of a whole. Let's say you have a pizza and you want to talk about how much you have eaten. So that's where fractions actually come in handy. Now this whole we are talking about could be one single thing, maybe like a pizza or a cookie, or it could be a bunch of things. It could be like a group of friends. But the point here, it's all about breaking down things. For example, maybe you have eaten only half of the pizza. The remaining half, maybe you have reserved it for your friend. Maybe you have 10 friends who are your, let's say, closest friends, and out of those 10 friends, 3 of the friends stay in the same lane or road. So now what we are essentially doing is we are breaking down things so that it will be easy for us to understand. Now, moving further, we'll look at all these things in detail when we work out the problems, but I'm just trying to cover whatever is there in this material. Of course, we can't directly go by this because there is nothing much here, and they have pretty much borrowed from NCERT. Anyway, now, if the number on top, for example, fraction, let's say 3 by 4, the number on top, that is 3, is referred to as numerator. Okay, if that numerator of our fraction is smaller than the number on down on the bottom, that's called denominator, then we call it as a proper fraction. Once again, let me just erase this. 3 by 4 is the fraction which I have considered here as an example. The number on top, numerator, number on bottom, denominator. 3 is smaller than denominator, numerator is smaller than denominator. Therefore, we call it what? We call it a proper fraction. For example, you may have had 2 slices out of 3 slices in a pizza. Again, it's a proper fraction. But if it's like this, that is 4 by 3, that is the numerator is bigger than the denominator, well, then it's an improper fraction. It's not improper as an improper manner, it just doesn't follow the rules. It's like you have 5 slices of pizza out of 3. That's an improper fraction. Then comes mixed fractions. Mixed fractions are a bit of both the worlds. They're like a whole number and a fraction hanging out together. So if you have 1 and 2/3 slices of pizza, 1 and 2/3 slices of pizza, then we have a mixed fraction. Now, here's a cool trick. You can actually switch between improper and mixed fractions. Take that 4 by 3 for instance, which we consider for the improper fraction. Now we can actually turn it into a mixed fraction. How? Very simple. I'll do one thing. I will use 1 as the whole number, since 3 and 1 by 3. That means what I'm essentially saying is I had 1 whole and little bit more of a pizza. So how much more? 1 and 1/3. So when I convert this into a fraction, not a mixed fraction, so 3 ones are 3 plus 1, 4 by 3. Now it has become an improper fraction. So that's how we convert an improper fraction to a mixed fraction. Okay, and the things get actually more interesting. That is, you can find other fractions that mean the same thing as the one you have, just by multiplying or dividing the top and the bottom by the same number. That means you divide the numerator as well as the denominator by the same number, and you will still get the same ratio but different numerators and denominator. I will tell you what. See, for example, 3 by 4. Okay, so now 3 by 4 could be something else also, by multiplying and multiplying the denominator as well as numerator by, let's say, 5. 5 3s are 15, 5 4s are 20. So this is also of the same ratio. Basically, it's all 75%. 3 by 4, we know, if I have to convert that into a decimal, all that I have to do is divide 3 by 4, 0, 0, 0.728, 2. Anyway, we had already put the point, so 0 here, 5. So that means all of this, whether it is 3 by 4, 15 by 20, 75%, or 0.75, they all mean the same thing. It's the same proportion. Okay, so that's about this page, I guess. Let's move on. Now, moving further, if we have a common factor between the numerator and the denominator, what we usually do is we try to divide this common factor. We try to divide the numerator as well as the denominator by the common factor and simplify it as far as possible. Let's take this as an example. Let's say 75 by 100. It is of course a big fraction, so but we did not have to retain as it is, because we know 75 as well as 100 both are easily divided by 25. So 25 times 3 is 75 and 25 times 4 is 100. So what we just now did was we brought it down, or we reduced it to the most simplest of their forms. So that is what we did in this case. And further, we know that if they have the same bottom or the same denominator, then we call them as like fractions. If the denominators are different, for example, let's say we are comparing two different fractions, 3 by 4 and 2 by 4. In this case, the denominator of both these numbers or fractions are one and the same, that is 4 and 4. So therefore, these are referred to as which type of fractions? Like fractions. If the denominators are different, then obviously they are nothing but unlike fractions. That's all. So pretty straightforward, right? So now comparing fractions can be a breeze actually. How do we compare them? Very simple. If at all they are not like fractions, for example, let's say we are comparing 4 by 5 and 6 by 7. Difficult to compare, no, because 4 parts out of 5, 6 parts out of 7, not so easy to understand. So since we have an unlike fraction here, convert that into a like fraction. Let me just insert a page here. 4 by 5 and 5 by, what was the number which I considered? 6 by 7, no? Okay. Doesn't really matter, but still. And 6 by 7. Of course, these are unlike fractions. So what I can do is, I can multiply this fraction by the denominator of the other fraction. So 7 and 7. 7 4s are 28, 7 5s are 35. And I can multiply this fraction by the denominator of the other one, that is 5 by 5. So this will be 30 by 35. Now, what we just did was, we converted an unlike fraction, that is 4 by 5 and 6 by 7, into a like fraction like this. 4 by 5 has now become 28 by 35, and 6 by 7 has now become 30 by 35. Now it's very easy to compare because we have the common denominator, and now it has become a like fraction. So which is obviously greater? 30 by 35. 30 parts out of 35 is obviously greater than 28 parts out of 35. So therefore, when we come back to this, now we can easily say 6 by 7 is actually greater than 4 by 5. This we couldn't have understood if we had not converted them into like fractions at the first place. So that's how we roll when it comes to fractions. Okay. So now further we can also look at the addition or subtraction from fractions. See, adding or subtracting like fractions is as simple as, let's say, stealing biscuits from a biscuit jar. Just add or subtract their numbers. For example, let me take this 3 by 4 plus 5 by 4. Very simple. Why? Because we have this, no? Of course, this is an improper fraction. Let me take another example. 30 by 100 plus 50 by 100. Now, addition of like fractions. Very simple. Keep on adding. That's all, because the denominator is same. Just add the numerators. 80 by 100. That's it. Okay. So, whereas if it is an unlike fraction, for example, 30 by 100 plus 50 by 150, then it would be difficult. Why? Because we are dealing with different denominators. When that is the case, we'll have to convert them into like fractions and then add. For example, in this case, what I will simply do is So now in this case we have different denominators. Obviously, unlike fractions, we cannot simply add it. It's not just like putting something together. So what I'm going to do is I'll just simplify it so that it will be easy for us to convert the unlike fractions here into like fractions. So 30 by 100 means 15 and 50. So further also it can be divided. I mean, I will divide this by 5. 5 6 are 5 20s are, so 2 3s are 2 10s are. So then here it will be 51s are 53s are. So now we have the 3 by 10 plus 1 by 3. Now we can easily convert them into like and unlike, from the unlike fractions we can convert them into like fractions by doing this. So 3 by 10 into 3 by 3 will be 9 by 30, and 1 by 3 into 10 by 10 will be 10 by 30. So now what I can do is 9 by 30 plus 10 by 30, because now we have the common denominator, so that will be 19 by 30. That's all. So what we essentially did was we first of all simplified these fractions which were unlike, and then converted into like fractions by multiplying the respective fractions by the other fractions denominator, and finally after we reduce them to the like factors, we just simply added the numerators, and we are done with it. So that's how we add unlike fractions. So I hope it is easily understood. If you have any doubts, of course you can just leave a comment below. Moving on, what else do we have here? Okay, decimals. Okay, fine. Decimals, again, it's one of the most easiest things to understand, because it is nothing but the extension of fractions. For example, if I divide this 3 by 4, if I have to reduce it, or rather divide this 3 by 4, what I will get is nothing but a decimal. So I have to divide the numerator by the denominator, and what we get is nothing but a decimal. See, fractions with denominators like 10, 100 and so on, then so when you write them with the decimal point, they become the decimals. Okay, let's move to the next topic, which is conversion of decimals to fraction. In this case, they've asked us to convert one particular decimal to fraction, which is 0.5. So now this we'll have to convert into a fraction. It's very easy. All that we need to do is imagine a denominator. There is no denominator, obviously, since it's only a decimal. So I will write 1, because 0.5 is same as 0.5 by 1. So now we have a fraction, but the problem is there is a decimal in the numerator, which we'll have to remove. That is easily done. How? By multiplying both the numerator as well as the denominator by 10. Why 10? Because after this point we have only one digit here, so units, so we'll units tens, what is it, just have to add 0, so that that decimal will get removed. So therefore I am multiplying by 10. It is not required to multiply by 100 as they have done. I don't know why they did so. So now in this case 0.5 into 10 will be 5 itself, and as I said, we'll have to multiply the denominator also by 10. So 1 into 10, obviously 10. So the simplified form of 0.5 is 5 by 10, or rather the fraction form of 0.5 is 5 by 10. Of course, we can further simplify this 5 by 10. 5 ones are 5 twos are, so 1 by 2. So from 0.5 we move to 1 by 2. That's how we convert any decimal into fraction. Maybe we can try one more number, in fact. So let's say 0.37. So how do I convert this into a fraction? See, here we have 2 digits after the point, so therefore we'll have to multiply by 100 because it has 2 zeros. So again, I will imagine a denominator which is 1, because 0.37 by 1 is same as 0.37. So how to multiply this, or how to convert this? Multiply by 100 on both numerator as well as denominator, which will come to 37 by 100. So this is how we convert this decimal into a fraction like this. Of course, you can say apply the same logic anywhere and it will still be the same. Moving on. Examples on fraction and decimals, okay, showcasing conversion and steps of conversion. Let's see what they have mentioned, given here. Current purchase 50 computers from a local computer market, only to discover that 10 of them were defective. Okay, I can just write it now only. 10 computers out of 50 turned out to be defective. So it is 10 by 50, or if I simply remove the zeros here, it would be 1 by 5. Can you calculate the fraction in decimals of the defective computers in relation to the total computers purchased by current? So we already did that. Let's see what exactly they have said. Out of 50 computers, we have 10 defective ones, correct? The percentage would, or rather the fraction would be like this, 10 by 50. So that is what they have done. Okay, if I have to further convert this into decimal, all that I have to do is divide 1 by 5. Obviously it can't be divided because 1 is a smaller number compared to 5, so I will add a 0 and point. So then I'll have to write a 0 here. So now 5 twos would be 10, so then we can divide it. So therefore in this case it would be 0.2 if you express that in terms of decimals. Let's say I want to express that in terms of percentage. So in that case what I do is just multiply by 100. So that would be 20%. That's all. So that's how we looked at the problem, and we reduced it to fraction, decimal, as well as percentage. Okay, all, of course, as I said in the very first class, all this what we have here, it's all basic stuff. It's something which you don't have to study afresh. It's already there. Maybe you'll have to just revisit those concepts. Okay, let's move on. In this case, they say in a 100 employee office, 50, there are 100 employees, okay, 50 people chose burgers as a snack. Why would anyone need that? While the other employees preferred mango juice. Okay, calculate the percentage of employees that choose a mango juice and give the result in decimals. Again, this is like maybe second standard, third standard maths. So 50 divided by 100, 50 have chosen burgers. Obviously remaining 50 would have chosen mango juice. That's all. So if I had to simplify this, it would be half, or if I had to convert this into decimals, it would be 0.5. So 0.5 burgers, 0.5 mango, 50%, 50% basically. Okay, write 1 by 2 in decimal. We just now did that. 1 by 2 is in fraction, so 1 2 0.05 10. So 1 by 2 when it is written in decimals would be 0.5. So that is the thing. Let's look at few sample questions on fractions and decimals. If 3 by 2 of a number is 9, find the number. Okay, 3 by 2 of a number, we do not know which number it is. Then when we do that, of that number, that is 3 by 2, we will get 9. So basically x into 3 by 2 would be 9. That is what we know. Excuse me. So now what we can do is we can just take this 2 to RHS. When we do that, 3 into x will be 3x and 2 into 9 would be 18. X would be 18 by 3, which is nothing but 6. So therefore that number which we had to find out is nothing but 6, because when you do that into 3 by 2, so you'll get 9. 6 3s are 18. 18 by 2 is 9. Moving on. Multiply 1 by 3 and 2.7. This again is basic math. There's nothing much to do here, but let's see what exactly they have done. So what they have done is they've actually multiplied. And how are the students expected to do without calci, without any working? Stupid institute, stupid policies. So 1.73 into 2.7, I would say just multiply directly. All this nonsense is not required. Then how many decimals are there? I mean, how many numbers are there after decimals? 1 2 3. Just put the dot, or yeah, after 3 digits, that's all. So this is straightforward multiplication. We don't have to look into that. That's kid stuff anyway. Solve the following. 4 minus 1 by 3. This is interesting because 4 is a whole number, whereas 1 by 3 is a fraction. Now how do we do that? Let's see. 4 by 1 minus 1 by 3 is what you will have to imagine. Then it will be much easier to do. Okay. So now let's take the LCM. 3 into 1, 3 would be the LCM. 3 divided by 1, 3 itself. 4 3s are 12. Minus 3 1s are 3. 1 into 1, 1. So this will be 11 by 3. That is the answer. So now What is the answer which they have given? Same 11 by 3 itself. They have converted that into decimals here. We can do that also. 11 by 3. 3 3s are 9. 2. 2 obviously can't be divided by 3 because 2 is a smaller number. So I'll put a decimal here. So 20. 3 6 are 18. Again 2. So 20. 3 6 are 18. This will go on and on and on. A rational number. So what we can do is we can round it off 3.67. That is what they have got as well. Next, 6 plus 3 by 7. Again, there is one whole number, then there is one fraction. 6 by 1 is what I will do. I'll take the LCM of this. When I do that, I will get 7 here. 7 divided by 1 is 7 itself. 6 sevens are 42. Plus 7 ones are 7 plus 3. So this will be 45 by 7. Of course, you can further simplify or rather convert that into decimals. Let's see how to do that. I'll just do it here. 45 by 7. 6 sevens are 42. So 42 is here. 3.0. 7 fours are 28. Again 2. 0. 7 twos are 14. Again it will go on like that. So you can continue further, but I'll stop at 6.42. They have gone up to 6.4285. You can keep on doing this. Okay, I think it will get divided. Let's see. Let me just check. So 6, no, 7 8s are 56. So that will be 4. Again 7 5s are 35. That will be 5. No, it will keep on going. I think it's not something which can be divided. It will be what, irrational number, because it's not recurring and not repeating. Hopefully that is the case. I'm not so sure, but that you can check. But you can stop at this 3 digits, 2 digits, depending on the solution which is given in the options. You don't have to worry too much. Okay, let's move on to the question number 4. The product of two numbers, they say, is 1.178. If one of them is 0 4 49, no, I don't think it's 49. It should have been 0.49. Find the other number. Okay, fine. So now what they're essentially saying is x into y is 1.178, but we know what is y, that y being 0.49. So something into 0.49 is 1.178. So what is that something? So easy, just bring this to RHS. So 1.178 divided by 0.49 is what is x. So 1.178 divided by 0.49, 0.49, ignore the decimals for the time being. So here we have 3 decimals. No, we'll have to multiply both by 100 and 100. Again, not even 100, it's more than that. Have to multiply that by 1000 and this also by 1000. So then again, this is something which you can't do without calculating. We can, but it will take time in the exam. You can't even work it out. So forget about this type of problems. Don't even think about it. I can still do it here though. Let's say if I remove that 1178 divided by, so here 490. Okay, 490 into 2. 490 into 2 would be how much? 980. So 492s are minus 1178. No, so we are left with 198. 198 can't be divided by 490. So what I have to do is put a point here. So that will become 1980. So 1980 divided by 490 would be 4. So that will be 2.40. Again, it will be recurring. So the answer is 2.40. That is, the other number is obviously 0.49 into 2.40. So that will probably fetch us something approximately equal to 1.178. Again, not gonna happen in the exam. You will not be able to do without the calci, without the working at least you can do and find out, but they don't provide any space for this, no. So forget about this. Moving on. 1/4 of a number equals 4 by 5 divided by 1 by 10. 1/4 of a number equals 4 by 5 divided by 1 by 10. So 1 by 4 of a number, of some number, equals 4 by 5 divided by 1 by 10. So this I can write it as 4 by 5 divided by 1 by 10. So, or 4 by 5 into 10 by 1. 10 goes above because reciprocal basically when we change the sign. So 1 by 4 of x equals 40 by 5. No, 40 by 5 or 8. 1 by 4 of x equals 8. So then all that we need to do is x equals 8 divided by 1 by 4 or 8 by 1 into 4 by 1 equals 32. That's it. So therefore in this case x will be 32. So that is the thing. I don't know what they're doing here anyway. Next, simplify the following. Again, this is something which will take a lot of time. They're saying NCERT examples, but I don't know to what extent they will actually ask these type of problems in the exam. Anyway, 2 by 1 plus 1 by 5. It's mixed fraction, no? So 2 2s are 4, 4 plus 1, 5. So I will just simplify it here only. 5 by 2 plus 1 by 5. That is one thing. So here also the same thing. 2 2s are 4 plus 1, 5. 5 by 2 divided by 1 by 5. So let's do this first. This will be 10 LCM. 2 5s are 10, 5 5s are 25. 5 2s are 10, 2 1s are 2. This will become 27 by 10. So 27 by 10 is nothing but the numerator. Likewise, in case of denominator, it will be slightly different because it will be 5 by 2, 2 2s are 4, 4 plus 1, 5, divided by 1 by 5, or in other words, 5 by 2, sorry, divided by 1 by 5, or 5 by 2 into 5 by 1. Again, the numerator and denominator gets changed when we bring it to when we change the sign. So 5 5s are 25, 2 1s are 2, so 25 by 2. So essentially what we have done is, so far we have reduced this. Let me erase this, not that of course. We have reduced the numerator to 27 by 10 and denominator to 25 by 2. So now we can rewrite the problem like this: 27 by 10 divided by 25 by 2, or 27 by 10 into 2 by 25. 2 ones are 2 5s are. So 27 by 5 into 1 by 25, which is nothing but, let me just rewrite here, 27 into 1 is 27 itself, 25 into 5 will be 125. The answer in this case would be 27 by 125. Question number 1. Let's see what they have done. So exactly 27 by 125. Again, similar problems are given. You can actually check it out. So it's not very difficult here. Again, it's a very simple thing: 1 by 4 plus 1 by 5. So all that you have to do is just take the LCM, which will be 20, and then reduce it to the simplest fraction. So in this case, what we can do is, so we have 1 minus 3 by 8 into 3 by 5, no? So this is easily done. 1 by 4 plus 1 by 5 means we'll have to take the LCM. That will be 20. 4 5s are 24. 5 4s are 20, which is nothing but 9 by 20. We have reduced this numerator to 9 by 20. So when it comes to denominator, we have 3 by 8 into 3 by 5, which will be 5 8s are 40, 3 3s are 9. So 9 by 40, 1 minus 9 by 40, that will be 40 ones are 40 minus 1 would be 31 by 40. So 9 by 20 divided by 31 by 40. Let me just clear this. 9 by 20 divided by 31 by 40, or 9 by 20 into 40 by 31. So 21s are 22s are. So that will be 9 2s are 18 by 31. That is the simplest form of that particular fraction. 18 by 31. That's all. Next, what else is asked? That's all, no? Okay, these things are very simple. Okay, let's move on to the next topic, which is the decimal fractions. Let's see what exactly they have got in store. Decimal fractions can be understood by considering normal fractions. Okay, a fraction has two parts, numerator, denominator. This we already know, a by b. So decimal fractions are those fractions in which denominator is 10, 100. Okay, fine. This is easy. So basically what they're essentially saying is 0.05. This is a decimal fraction because we have either 10, 100,000, 10,000 as the denominators. Here also we can see that 0.05 can also be written as 5 by 100. So this is a typical decimal fraction, or mm, 0.5 can also be written as 50 by 100. So where we have 110 as the denominator. So again, there are a few examples here. 0.09 is nothing but 9 by 100. 1.80 is nothing but 180 by 100. So all these are decimal fractions because we have these as the denominators. Now there are a few examples of non-decimal fractions wherein the denominator is not a multiple of 10. So for example, 25 by 9. Of course, this can be converted into a decimal fraction. That's a different matter altogether. But these are straightforward examples where we do not have um, denominators which are multiples of 10, 50, sorry, 10, 100, 10 basically. Next, significance of decimal fractions. Decimal fractions inspire individuals to study about accurate quantities. Okay, recognize weights like 9.2, distances like 5.5. Okay, basically we are trying to be as accurate as possible instead of rounding off. That's fine. Conversion from fractions to decimal fractions. Okay, they're given one example, 9 by 2. So of course we'll have to use a multiple of 10. So therefore all that we can do is 9 by 2 into 10 by 10. If we do that, we'll get 90 by 20. If I further simplify this, 2 tens are 2 45s. Now we have denominator of 10. Now it has become a perfect decimal fraction. Earlier it was not a decimal fraction because the denominator was not multiple of 10. So the denominator back then was 2. Again, it doesn't work that way. So that is the thing. Conversion from decimal numbers to decimal fraction. Okay, that can also be done. So we have a decimal number 9.5. So we know for a fact that any decimal is also a fraction if you divide that by 1. So now all that we have to do is just multiply both by 10. So 9.5 into 10 becomes 95 and 1 into 10 becomes 10. So now we have a decimal fraction because the denominator is obviously a multiple of 10 because in this case it is 10 itself. So that is the thing. Okay, there are a few examples. Let's see. Convert 5 into half into a decimal fraction. 5 into half into a decimal fraction. Okay. 5 into 1 by 2. This will be 5 by 2. So into 10 by 10. 50 by 20 or 2 tens are. So this will be 25 by 10. That's all. Easy. 9 by 9 decimal fraction. This is easily done. Okay, let's move to the next topic, the last topic in this chapter, which is relationship between numbers. Okay, moving on. Relationship between numbers. In this case, we are looking at what exactly maths does when it comes to numbers. In fact, much of it is actually borrowed from real life. Mathematics is all about recognizing some kind of a connect or a pattern, kind of a link, so to say, between quantities that change. In our daily life also we come across many patterns that kind of characterize relationships such as brother, sister, father, mother, teacher, student, whatnot. So here also in maths we come across many such relations, such as, let's say, number a is less than number b, maybe line x is parallel to line y, maybe set b is a subset of set c. So in all these we notice that a relation involves a pair of objects in certain order. So that is what they have mentioned with respect to the relationship between numbers in this case, and much of that is theoretical in nature. You don't have to study this in detail. There is no way they will be able to ask this because this has been copy pasted from NCERT textbook. It doesn't hold much of relevance. You can just go through that as a story. I don't want to read whatever is there already, so I'll just skip this part because all these things are not part of they can't ask. Basically, we are looking at exam point of view, and this is obviously something which won't be asked. So now let me just directly jump to this types of relations in mathematics. Hmm, again, that is also not relevant. Okay, this is what we want. So the order relations including strict orders, okay, these are specific relations which can be expressed in clear terms. There won't be any ambiguity. In fact, maths itself is like that. In fact, one of the examples which is given earlier is think about like for example, Mary is the sister of Curie and Curie is the sister of Mary. It's like a two-way street, like friendship thing, but you can't be sort of a sister. Either you are or you are not. There is no middle ground here. So that's what we look at the strict orders here. Greater than, which is denoted by this symbol. For example, 5 is greater than 2. Score of 340 is greater than 339. Maybe it's a cricket match which we are referring to. Then less than, again the reverse of that. 1 is less than 5. 1 is less than any natural number for that matter. Less than or equal to, 1 is less than or equal to, again we don't express this directly as such, it's usually put forth as a condition. So anyone who scores less than or equal to, let's say, 39 is considered to be considered to have not passed that particular exam. So that is where we can easily use this type of relations or strict order. Then we have divides, that's fine, that's just dividing, and subset of, maybe there's a whole set of A containing the whole population of India. That is one set. The subset of this would be, let's say, population of Karnataka. So this is one whole set, and the subset is population of only one state in the entire country, maybe population of Tamil Nadu. That is also another subset. So equivalence relations, equality. So 4 equals 2 plus 2. We are looking at the equivalence. Then parallel, for example, these are two parallel lines. Is in bijection with isomorphic. So then we have bijection, which has got something to do with the sets, and isomorphic, similar kind of numbers, but maybe it's like, think of an SUV or a sedan. Both are cars, maybe both would take you to the same place but different forms. So that is what isomorphic deals with. Again, not very relevant here. Okay, so now that's about the theoretical part with respect to chapter 1 in QA. Let's look at the problem sample questions on relation between numbers. If 1/2 of 1/3 of a number is 20, half of 1/3 of x is 20, they say. Okay, then 1/10 of that number would be how much? Fine, let's see. So 1/2 of, okay, let me just 1/2 of 1/3 x equals 20. So x equals 20 into 2 into 3, no? So that will be x equals 120. How? Because it's in the LHS and it's in the denominator, both 2 and 3. So when I multiply this and take it to RHS, I will have to shift it to the numerator, so it becomes 20 into 2 into 3. So that is nothing but 120. So x is 120. So now what is 1/10 of that number? What is the meaning of 1/10? I think it is half of that number. So half of that number would be 120 equals 60. That is what they have mentioned here too. But there is a printing mistake here, I guess. It is not 20 into 2 into 2, but instead it should have been 20 into 2 into 3. So that is in fact a mistake. So let's move on. The difference between a 2-digit number and the number obtained by interchanging the position of its digits is 54. What is the difference between the 2 digits of that number? Okay, so those 2 digits, x and y. Okay, let me just zoom into this only. Let's the tens digits be x and the y units digits be y. Okay, what they're essentially saying is difference between a two-digit number. No, we do not know which two-digit number that is, x, y. It could be 10. I'm just giving you an example. So tens is x and units is y. That's why they refer to it as xy. Now the difference between two-digit number and the number obtained by interchanging the position of the digits is 54, they say. Okay. 10 into x, because it's in tens position, plus 1 into y, so which is y only. Okay, the difference between that and 10y. Now we are changing the numbers. 10y plus x equals 54. That is what we have done. So now if you solve for this, this will be 10x plus y minus 10y plus x. So that will be 11x plus, actually 11x minus 9y. Is it correct? Oh no. So now minus, okay, sorry, my mistake. So this will be 10y minus x, because minus into plus. Therefore this will be 9x, 10x minus x, 9x, 10y minus y minus 9y, because 10y is the number with the negative sign, equals 54. So if I take 9 out, then it will be 9 into x minus 5 equals 54. So x minus y therefore will be 54 by 9. I'll take it to RHS. The function will also change, which is nothing but 6. What is the difference between the two digits of that number is what they had asked. So the difference is nothing but 6. Okay, moving on. The difference between a two-digit number and the number obtained by interchanging the digits is 54. What is the difference between the sum and the difference of the digits of the number if the ratio between the digits of the number is 4:1? Okay, let's look at this. Now with respect to the rest of the questions, these are questions which will take a lot of time for you in the exam if at all you attempt, and 100% I'm sure that they will not ask these type of questions, because for for one, you need a working paper to solve these type of questions. Without it, there is no way you'll be able to solve using the mental ability which the institute expects you to. So I'm just skipping all this part and directly proceeding towards the next chapter, which is mostly practical in nature. So what we did so far is chapter 1 of QA, or chapter 6 in the overall order, I guess. So this is largely theoretical in nature, but again, this is where you can expect questions, mostly theory only. Okay, fine. If at all you have any doubts, you know where to contact us. I hope this was of some use.
I'm here again to remind you that go to the description, and in the description please click Excel Academy website. Go to the free CACET course. You'll get lot of resources like quizzes, like mock exam plus practice test. All of that you'll get. Please go to the description and you'll get the details.
Fine, then let's move on to the next lesson, which is lesson number 7, fundamental arithmetical operations. This is the easier lesson compared to the previous one, because previous one was mostly theory, whereas here it is mostly the basic operations, which is which are the addition, subtraction, multiplication and division. It's mostly about that with bits and pieces thrown in. Okay, let's start this. Fine. So now this the word arithmetic itself, they say, comes from the Greek word arithmos. Point to be noted, because sometimes these type of questions creep in the exam, because the institute, even though it's a practical part of the CSET exam, sometimes they want to throw in theory questions as well. Let's see. So this Greek word arithmos means what? Number. Fine. Essentially, the arithmetic covers the ABCs of numbers. That is the fundamental stuff. We are mostly talking about the three things here, which are those: the theory of numbers, wherein we are understanding the essence of numbers, the art of mensuration, fancy word, but it's just measuring things. That's all, nothing much. Then finally, we have the numerical computation, doing the math, adding, subtracting, multiplying, dividing, and all that jazz for you. So this is what we are referring to when we say arithmetic or arithmos according to the Greek word. So now let us look at the basic arithmetic operations. So what are these superhero moves of arithmetic? Well, you can think of them as the Fantastic Four, which are those plus, minus, multiply, and divide. And these operations are like your Avengers of math, always there to save the day. They're not just numbers on the paper, they're your everyday heroes, helping you figure out income, expenditure, balance sheets, you name it, and they're there. And since sometimes what happens, all the four will be simultaneously, sorry about that. Yeah, fine. Sometimes what happens, all the four will be simultaneously present, and then what to do, which to take up first. So there comes our most important rule of BODMAS. So what is this BODMAS now? Of course, I don't think they have mentioned here. Okay, they have mentioned. Yeah, B stands for bracket, meaning deal anything with within the brackets first. It's like giving priority to the VIPs in the math world. Okay, fine. O for order. Handle any powers or roots next. Like they are the cool friends of VIPs, who have to be taken care of after the brackets. Then comes DMAS, that is D for division, M for multiplication, A for addition, and S for subtraction. That means first we look at brackets, whatever is there in the brackets we do it because we have to give priority to them. Then of course order, which you won't encounter usually. Then comes division, first take up division, then take up multiplication, then take up addition, and lastly take up subtraction. So that is the thing. Okay, this is easier said than done. Sometimes there will be some confusion. I'm sure this is elementary, but still let us take up some example and then try to understand how this rule actually works out. Okay, let me just think of something. Oh, okay, 4 plus 3 minus 2. 3 minus 2, I'll do one thing. 3 into 2 minus 5 divided by 1. So this is the thing. You can use the divide sign if that is confusing. So now we have the addition, brackets, multiplication, subtraction, and the division as well. So now, as the rule itself says, brackets, order, divide, multiply, add, and finally subtract. First we'll have to take whatever is in the brackets first. So I will keep on rewriting this, applying the rules. 4 plus 6. How? Because 3 into 2, they are within the brackets, so deal with it first. So 4 plus 6 minus 5 divided by 1. So now that we are done with brackets, order, the next thing which comes up is division. So take care of this next. So I will rewrite this now as 4 plus 6 minus 5. So finally we do the addition and subtraction from left to right. So from left to right. So 4 plus 6 minus 5 can also be written as 10 minus 5, which is nothing but 5 itself. So that's how we cracked it here. We looked at one particular problem here. We applied the BODMAS rule and finally we got the answer. So it's as simple as this. I don't think there is any scope for confusion here. Okay. Okay, now let's look at the types of fundamental arithmetical operation. We already mentioned these. No, the same thing, right? Nothing else. Addition definition. Let me go through this first. What are these definitions? A mathematical operation of adding items together is addition. Fine. The plus sign indicates that something is to be added. Fine. It entails adding two or more integers together to create a single number. Of course, yes. 10 plus 10, two or more different integers adding together to get a single number. That is addition for you. Okay. Any type of number including real and complex number. Of course, yes. Here, rational, irrational, everything can be considered. For example, 3.12 plus 5.67 can also be added. Okay, doesn't really matter whether it's a negative integer, positive integer, whether it's a rational number, irrational number, whatnot. Okay, whole number, natural number, whatever it is, we can still add. 6 plus 1, 7, then here 5 plus 3, 8, 8.79. Two numbers forming one new number. That is what we have here. Okay. The addition of more than two numbers, values or term is also known as summation, which I'm sure you are familiar with. So that is there. Addition rules. Let's look at the rules of addition. A positive integer is the result of adding two positive numbers. For example, 10 plus 20. Both are positive numbers. There is no minus sign here. So we get 30, again a positive integer. A negative integer is created by adding two negative integers. Okay. For example, minus 10, minus 10. So both are minus. So we add those two numbers as such and retain the negative sign. So minus 20. Okay. When subtracting positive and negative integers, utilize the sign of the biggest integer value. Okay, this is interesting, because when we are dealing with the same sign, it is always easy. Plus and plus, minus and minus. What if there is plus as well as minus involved together? For example, minus 45 plus 30. Now how do we deal with this? It's very simple. So 45 is the largest number, use that sign. Okay, so minus 45 plus 30, that means we'll have to deduct from 45, which will be obviously 15. But which 15? Is it positive 15 or negative 15? Again, we'll go back to this rule. When subtracting positive and negative integers, utilize the sign of the biggest integer value. The biggest integer value is 45. Its sign is 45, so therefore it will be minus 45. That's the thing. Okay, so yeah, subtraction definition. Let's move on. The difference between two numbers is revealed by the subtraction procedure. Difference between two numbers. For example, let's say India scored 245 runs in a match and Australia scored 230. So the difference here is 15 runs. For example, let's say India batted first and Australia batted second and scored and scored only 230 runs. So now what do we say? India won by 15 runs. So that is the thing. That's what subtraction does. It is addition done in the opposite direction. Fine. Subtraction is the act of combining a positive term with a negative term. So for example, 245 minus 230. So the positive term is 245. We don't write that here. Even if you don't write also, it is always known that it's a positive term. And here it is clearly specified that it is negative. So 245 minus 230 will be obviously 15 runs. India won by 15 runs, which they did not, but that's a different thing. Fine. Let's move on. The term can also be rewritten as 14 plus, okay, they're given something like this, 14 minus 5. You can also rewrite it as 14 plus minus 5. So minus into plus will be always minus. So therefore 14 minus 5, we have, what is this that they have done? 9. Adding the terms, we have 7. How can you get 7? I wonder what are they even doing. Okay, of course, when you copy from other material, you probably copy the mistakes as well. Subtraction rules. Let us look at the rules of subtraction. I'm just checking if the recording is working. Yeah, it is fine. Moving on. Where are we? Subtraction rules. What are these subtraction rules now? Both the numbers are positive, then the answer will be positive. That's very simple. It's more or less like additional rules only. 50 minus, if both the numbers are plus, the answer will be positive. If both the numbers are plus, how are we even getting, what is that they're trying to say? How can you even subtract? Anyway, how can there be both plus numbers? Okay, maybe they're referring to this plus minus of 45. Maybe this is what they're referring here. So this will obviously be 5, because plus into minus again will become minus 5. If both the numbers are negative, the answer will be negative. That is something which we already know. For example, minus 5 and minus 10 will be minus 15. Okay. And if one number is positive and the other number is negative, the answer will be the sign which is largest. Same as addition, no change here also. So let's say if we are looking at minus 100 plus 85. So this will be 15. Which sign should I use? Minus, because the largest number is 100 and its sign is negative. So we use the negative sign. Done. Moving on. Multiplication definition. That's the next function. Repeated addition. If someone asks you to define multiplication, this would be the most simplest addition. What is that definition? Repeated addition. For example, 3 into 3 is how much? 9. What exactly we did here was we repeated the addition, that's all. So that is same as this. Multiplication, I would say, is there's nothing but the extension of addition. Okay. So now it is indicated by X, or what is this? Oh, this the into sign. Okay, in computer language it would be a star, but whereas if we have to write manually, we will write the X. Additionally, it can combine with two or more values, other values, to produce a single value. Fine. Multiplication, the multiplicand and the multiplier are both involved in the multiplication. Each has a term, multiplicand and multiplier. It doesn't make, I mean, it's not required for us. The outcome of the multiplying and the multiplicand and the multiplier actually by the multiplier is referred to as a product. Okay, fine. 5 into 6, 30. Fine. These are all basic stuff. I don't want to get into in detail here. Let's look at the multiplication rules. The product of two positive integers is always positive, that is for sure. 45 into 2 positive will be 90 positive. So if in a multiplication, if one number is positive and the other number is negative, then the answer will be negative. This you have to remember, because minus 45 into 2 would be minus 90. Minus into plus would be minus. Even if it was a small number, for example, if it was plus 45 into minus 2, it would still be 90, because we are looking at one number is positive, the other number is negative, the answer will be negative. There is no question of what is the sign of the largest number like we do in subtraction or as in addition. Here we just look at the sign and decide. In multiplication, if both the numbers are negative, the answer will be positive. So for example, minus 45 into minus 2, in this case minus minus will get cancelled and it will become positive 90. So that's what it is. So that's about the multiplication. Next is the division. Let's look at that. Okay, let me bring it up. So the inverse of multiplication is division. Inverse of multiplication, for example, here we say 3 into 3, here we say 3 divided by 3. So 1, which is typically represented by the symbol this divided by. It consists of words divided, dividend and divisor, quotient, remainder, all those things will come into picture here. Fine. So there again example, 8 by 4 is 2, 8 is the dividend, the one which is getting divided, 4 is the divisor, the one which is dividing, and the result 2 is called the quotient. There is no remainder here, so you don't have to worry about that. So now let us look at the rules of division. The positive integer is obtained by dividing two positive integers. For example, 90 divided by 2 would be 45, 50 divided by 5 would be 10, positive. The positive integer is obtained by adding two negative integers, by dividing two negative integers. Okay, minus 45 divided by minus 9 will be 5. Two negative integers, when they get divided, it will be 5, a positive. Okay, a negative integer is produced when you divide two integers with different signs. So in that case also you will get negative, which is similar to multiplication. For example, minus 45 divided by 9 would be minus 5. So that is the thing. So what else? Division rules is done. Now let us look at basic arithmetic properties. Let's see what are these. The basic arithmetic properties for real numbers are commutative property, associative property, distributive property. Again, simple stuff, something which you already have seen n number of times in different classes. So let's still go through this. This property is applicable only for two arithmetic operations, that is addition and multiplication, not for division or subtraction. Suppose a and b are two numbers, then according to the commutative property, even if you change the order also, it's still the same. For example, a plus b will be the same as b plus a, meaning even if I change the order here, in the LHS a is first, in the RHS b is first, but still LHS will be RHS. Whereas we can't do this in case of division or in case of subtraction. I will give you an example here. Let's say, let me write it here. 4 plus 5 equals 5 plus 4, 9 and 9. Okay, let me take another example. 10 plus 20 equals 20 plus 10. This I can't use in multiplication. Multiplication I can use, sorry, I can't use in division. 10 divided by 20 is not equal to 20 divided by 10. Different answers, totally different. Okay, I can't use in subtraction also. 10 minus 20 is not the same as 20 minus 10. Here it will be minus 10 because 20 is greater and we'll have to use its sign. And here 20 is greater, again we'll have to use its sign. So it will be 20 minus 10, positive 10. So this commutative property is applicable only for, as they say, addition and multiplication arithmetic operations and not for division or subtraction. So they have given an example, 5 plus 2, 7 is equal to 2 plus 5, which is also 7. At the same time, we can use it for multiplication also. That is 4 into 5 equals 5 into 4. That is 20 equals 20. That we know anyway. Associative property. Let's look at that. Like the commutative property, the associative property is also applicable in addition and multiplication. Here also we are looking at slight extension of the commutative property, not very different from what we have already seen just above. So here a plus b plus c equals a plus b plus c. That means we are grouping b and c together. Here we are grouping a plus b together. For example, 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. That's all. So that is what we are doing here. We just group the numbers differently. So when it comes to this, it will be 1 into 2 into 3 equals 1 into 2 into 3. So again, in any case, it will be 6 and 6. You can take any number for that matter. It's not just these simple numbers. So you'll still get the same answer. For example, 10 into 5 into 2 equals 10 into 5 into 2. That means 5 2s is 10. 10 into 10 is 100. So 10 5s are 50. 50 into 2 is 100. Again the same thing. So that is the associative property. Two numbers get associated, or when you are grouping something, you can still interchange the group and still the answer remains the same. So that was our associative property. Next comes the distributive property. Let's see what exactly this is. According to the distributive property, if a, b and c are the three real numbers, then here we are slightly changing. Again, we are now looking at the signs as well. Okay, so if they are all real numbers, then what can we do? A into b plus c. So now we multiply a into b and a into c, and it will still be the same. If you take the example, 5 into 6 plus 7, that's all. So is equal to 5 into 6 plus 5 into 7, that's all. So 6 plus 7 is how much? 13. 13 5s are 85. So now here 5 6 are 30, 5 7s are 35. I made a mistake here. So this is not 85, 65. Sorry. Okay, 13 5s are 65. So yeah, that's it. So now 65 equals 65. Take another example. Let's say 7 into 8 plus 9 equals 7 into 8 plus 7 into 9. You can try this. 8 plus 9 is how much? 17. 17 into 7. Let me do this. 7 7s are 49. 7 1s are 7. 10 11. No. Yeah, 119 it is. 7 8s are 56. 7 9s are 63. 63, 9, 11, 119 and 119. That's all. So that's the distributive property for u. Again, they have given few examples. They've taken the same example, is it? Which I took. No, different. Okay. Now we have few sample questions on BODMAS. They only considered DMAS. BO is not considered here. That is what they are trying to tell us. Let's see what exactly do we have in store. Let me just bring it up on screen. Okay. Add 30 and 45 and then subtract 20 from the sum. Easy. 30 plus 45 is what we have to do first. That is 75, and from 75 you subtract 20, you will get 55. Done. Solve 10 plus 10 plus 10. This can also be solved in a different way. 1 2 3 4 5. No? So then it can also be written as 10 into 5, which is same as 50. Find the value. Here we will have to look at BODMAS. Okay, first bracket, 6 4s are 24. Okay, then divide 12, that means 2 plus 72 divided by 8 minus 9. So then consider this, that will be 2 plus 72 by 8, 8 9s are minus 9. So from left to right you just do the addition and subtraction. 9 plus 2, 11 minus 9 would be again 2. That is the thing. So that is what we have here. I hope it is clear. This BODMAS is actually very easy, not difficult at all. Now again, 24 minus 4 divided by 2 into 3. So first do the division. So that can be rewritten as 24 minus 2 into 3. Then do the multiplication. So that can be rewritten as 24 minus 6. That is nothing but 18. That is what they have got here, 18. Next. Simplify 24 by 4 into 3 plus 2. 24 by 4 is what we have to do first because it is division. So 6 into 3 is what we have to do next, plus 2. So that can be rewritten as 6 3 is 18 plus 2, which is 20. That is the thing. Next. Simplify minus 20 plus minus 8 divided by minus 2 into 3. So first do this because this is what we are supposed to perform first. So minus 8 divided by minus 2. So we know the division rule where both divisor and the dividend are negative, the quotient will be positive, so this will be 4. So this can be rewritten as minus 20 plus 4 into 3. So do this first. 4 3s are 12. So minus 20 where is that? What is that? Plus 12, which is nothing but minus 8 because 20 is the largest number and its sign is negative. So we'll retain that. So it will be minus. Okay, let's move on. Simplify again. We have BODMAS rule here. So first do the division. Both have negative sign. So therefore the result will be a positive number. 16 threes are, is it? 16 threes is 48. So minus 5 minus 3 plus minus 2 into 6. So do this first. So 5 minus 3 minus 12, because any positive number when it is multiplied by a negative number will result in a negative number. So that will also be negative, that is minus. So all the three will have to just add and retain the sign. 5 plus 3, 8, 8 plus 12, 20. So minus 20 is the answer which they have got here as well. Moving on, simplify 52 minus 2 into 6 plus 17. This is easy, you can only do it, but still 2 6 are 12, 12 plus 17 is what we are, or rather we can do from either side, it will still be fine. Minus 12 plus 17. You can either do this first or this first and the answer will still be the same. 52 minus 12 is 40, 40 plus 17 equals 57, or you can write 52 minus 12 and plus 17 will be nothing but plus 5. So because positive sign has to be considered because the largest number is positive, so this will be 57 once again, which is the answer which they have got. So that's about the basic operations introduction to the second chapter or lesson 7 in the overall scheme of things. Okay, the next is formula of percentage or percentage formula. How to calculate percentage, etc., etc. So let's look at the percentage first of all. I mean, of course, this is something which we already know, but still, let us look at the Britannica dictionary definition. Percentage is a relative value indicating hundredth part of any quantity. For example, if I say 5%, then we are saying 5 by hundredth of a particular like quantity or whatnot, because 100 is the base which we are considering to measure something. For example, you may say, I have 5 chocolates left out of the 10 chocolates which my father presented to me. So then how do I express this in percentage? What I do is I'll convert the denominator to 100 and then measure the percentage. For example, in this case 5 by 10 into 10 by 10, you will get 50 by 100. So now what is the percent? How much percent of chocolates is already over and how much percent of chocolates is left? 50%. So that is what we are referring to here. Percent per 100. 100 being the base, standardized base. That's all. Again, there are a few examples. Let us quickly go through this. 1% of 1000 books. 1% of 1000 books. 1% of 1000 books. Okay. So then just remove the zeros here. You will get 10 books. That's all. So we have 10 books. They are referring to 1% means 10 books. 20% of the quantity is again 20% of 1000 books. So then again remove zeros here. It will be 200 books. Okay. These relationship may be generalized as x pt by 100, where pt by 100, pt by 100, where t is the total reference quantity chosen to indicate the 100% and x is the quantity equivalent to a given percentage of p and t. Okay, that we have already seen here. Again, percentage formula is very simple. Value by total quantity. For example, in this case 3 by 5, 3 is the value, total quantity is 5. 3 out of 5 students have cleared CSEET. So now what is the percentage of students who appeared and cleared. This is, let's say, appeared, and these are the students who actually cleared CSEET. So now how do I convert this into percentage? Very simple, 3 by 5 into 100, that's all. So now this, whatever is the value, for example 5 we know is nothing but 20, so 23 is a 60%, that's it. So 60% of the students cleared CSEET, we can say, by considering 100 as the base. If only 10 of the 200 apples are bad, what percentage is that? Again, value 10 divided by total value, which is 200 into 100. So 0 zeros will get cancelled. So this will be 5%. 2 ones are 2 5s. To calculate the percentage, what happened here? Anyway, let me just quickly erase this. Okay. To calculate the percentage of a number, we need to use a different formula, such as percent of a number x. Okay, we don't need all that, we know how to do that. Okay, now let us look at few problems. 20% of 80. So there is a simple trick, just consider this is how we write now usually. So now we know, since it is percentage, there will be 2 zeros in the denominator. So make sure that zeros are cancelled. How? By cancelling the zeros, equivalent number of zeros in the numerator as well. So 80 into 20 by 100. So 0 0 0. 8 2s are 16. So therefore it is 16%. So that's how we can easily identify. Okay. Then calculate 25% of 100. This is easy. 25 by 100 into 100. So 100 gets cancelled. So therefore it is 25% itself. 30% of 400. So 400 into 30 by 100. 100 ones are 100 fours are 4 threes are 120 apples. So 30% of 400 apples are bad. How many apples are bad? 120 apples are bad. A mobile is reduced to 25% in price. The old price was 120%. Find the new price. So 120 into 25%. That is the thing which we have to do. So 120 into 25 will be how much? 5 2s are 10, 5 1s are 5, 6, 24, 0, 0, 30 rupees is what is reduced. So 120 minus 30, 90 rupees is the new price. Okay, so that is what we have here. Okay, then variables of percentage. Let's see, every percentage problem has 3 possible unknowns or variables, which are those: percentage, part and base. Fine. In order to solve any percentage problem, you must be able to identify these variables. Look at the following examples. All the 3 variables are known. Okay, fine. Again, obvious stuff, but since it's there here in the material, we'll just looking at it. These are the kind of questions which you can expect, because this is very easy to solve also. 80% of 20 is 16. So 80 is the percentage which they referred to earlier. That is the 3 different parts of a percentage. And what is the base here? 20, because 80% of what? 20. Okay, so that is the base, and 16 is the part. So 80%, when you do that, you will get the part. So let's say 16 into 80%. So how do I sorry, 20 into 80%, no, yeah, sorry, 20 into 80% is nothing but 20 into 80 by 100. So again, zeros will get cancelled. All that will be left with 16%, or rather 16, whatever that thing is, unit is. Then 50% of 200 is 100. That is easy. 60% of 50 is 120. 120. Sorry, 60 is 50% of 120. 50%, when you do that, you will get 60. That's easy. Increase or decrease percent. Okay, let's see. We often come across such information in daily life as 25% of MRP. That means you go to a supermarket, maybe they have put up a notice saying that today we are running a discount of 25% off on all the products. List price MRP, let's assume. So if the price listed here is 100, we will give you a discount of 25 rupees or 25%. Or if the price is, let's say, 500, you will get 25% discount here, which is nothing but 125 rupees. How did I do that? 500 into 25 by 100. So this will get cancelled. 525 is a 125. So 125 rupees is the discount which we are getting because of this. 10% hike in the diesel price. Okay, diesel price was 90. So now they have hiked 10%. That is 90 plus 10%. So 90 into 10 by 100. So zeros will get cancelled. 9 rupees is what has increased. So to the old base, add this part of 9, you will get the new number, which is 99. So it has now gone up to 99. Fine. What else then? Let's see. The original number is subtracted from the new number, divided by the original number, then multiplied by 100 to get the percentage increase. This is exactly what we did here. Or we can even try this the other way around. Whatever they have mentioned, I'm just using the same data. Let's say 99 is the new price, 90 is the earlier price. Now if they ask what is the percentage increase in diesel price, this was yesterday's price, this is today's price, by how much percent did the price increase in diesel? So 99 minus 90, 9 rupees. So 9, that is the difference, divided by old into 100. So zeros will, 10 gets cancelled, 10 here. So 90 by 9, so it is nothing but 10%. So the price has increased by 10%. So that is what they have here. A percentage decrease is calculated by subtracting a new number from the original number. Fine, it's the same thing actually. We'll see with a different example. So here it's the other way around. Let's say same thing, no? I don't know why. Okay, let me look at the examples. Maybe that way it's much easier for us to understand. The price of the laptop last year was 40,000. Fine, it has increased by 25% this year. What is the price now? Very simple. 40,000 plus 25% is what we are supposed to do. But we do not know what is the 25% of 40,000. So 425 is 100. 100 means here 10,000. So that's easily done. So we can do this way also. 40,000 into 25 by 100. I'll simply cancel these zeros. Okay, now ignore these two zeros for the time being and multiply 4 by 25, which is 100. Now get back these two zeros. So now when I do that, we get 10,000 rupees. So that means if the price of the laptop was 40,000 last year, and if we say it has increased by 25% this year, that means 40,000 plus 10,000, which is 50,000 now. So that is what the price of the new laptop is according to the problem. Okay. Again, the other way around. Okay. Earlier it was 100. Now it has become 125. Earlier it was 40,000. Now what would it be if we consider 100 as the base? Okay, because 25%. No. So now all that we need to do is cross multiply 40,000 into 125 by 100. So this will get cancelled. 125 into 4. 4 5s are 20, 4 2 8, 9, 10, 4 1 are 4, 5. So 2 zeros. So 50,000 is the new price. This is another way. They call it unitary method. Without accounting for the differences, we can directly arrive at the value of the laptop after the increase in percentage by 25. So that is one more way. Okay, suppose in order to increase itself, the price of the laptop was decreased by 10%. Okay, price of the scooter is 40,000, reduction of 10%. Again, this is also easily done. So they wanted to increase the sales of something, they reduce the price by 10%. Or let's say 40,000 was the price of the laptop, they decreased the price by, let's say, 20% to keep the calculation easy. So all that we have to do is 40,000 into 20 by 100. So if you do that, you will get 8,000 as the answer. So what is the new price? 40,000 minus 8,000, which is 32,000. So if I have to do the same using unitary method, so what I can do is, earlier it was 100, now it has become 80. No, 80. Earlier it was 40,000. How much has it become now? So that would be 40,000 into 80 by 100. Zeros will get cancelled. 4 8s are 32. Put 3 zeros, you will get the answer. So this is called unitary method of calculation of percentage. Next, Finding discounts in percentage. Again, we did that actually. Anyway, discount is a reduction given on the mark price. Fine. Usually this is done to encourage the sales of the product. That's also fine. So discount is nothing but marked price minus selling price. Fine. If the mark price is 1500, there is a list price. It's listed on the shelves at 1500, but I'm selling at 1250. So now the discount would be 250 rupees. So again here they have given one more example. 1000 is the mark price, but they are selling for 920. So discount is 80. So how to calculate the discount percentage? Difference divided by original price into 100. So when you do this, so you will get 8% as the answer. That's all. You can also find discount when the discount percentage is given. That means you can also find the discount amount when the discount percentage is given. Let's see. The market price of a keyboard is 300. The discount is 15% announced on sale. What is the amount of discount on it and its sale price? Very simple. 300 is the original price. The discount percentage is 15. So 15% on 300 would be 45 rupees. So the discounted price would be original price minus 45, which will be 255. That's it. So again, you can use the unitary method also to find out the same thing. Earlier it was 100, now it has come down by 15, which is 85. Earlier it was 300. How much would be the price now? So that would be 300 into 85 by 100. So cancel. 3 5s are 15. 3 8s are 24 plus 1 25. 255 is the answer. Next, estimation in percentages. Okay, let's say that the total bill of a restaurant is 919.78 decimals and the restaurant gives a discount of 15%. How would we estimate the amount to be paid? Okay, so here in the exam you can't calculate all this because obviously calculator is not allowed, working is not allowed because of the stupid rule by the institute. So therefore they say round off to the nearest whole number. Okay, so when I round it off, I'll round up because again we have already seen anything equal to 0.5, equal or above 0.5, greater than or equal to 0.5 would be rounded off to the next number. So here also, since it is 919.78, we'll round off to the next number, which is 920. So now find 10% of this. Okay, so 920 into 10%, so that will be 92. Then they say take half of this. Okay, why are they taking half? Okay, they want to give 15% discount now. Okay, so they're indirectly trying to find out without calculating directly. Okay, this is another way. In exam you can actually use this way. Interesting. So 920, instead of calculating 15% directly, what they're trying to do is first take the 10%, which is easy to identify, 92. Now they want 15%. Now how much percent to be added? 5%. So 10% half is again 5%. So half of this, which will be 46. So the discount is actually 92 plus 46. So 6 plus 2 8, 9 plus 4 13, 138 is the actual discount. So from 920 we can simply reduce 138. You'll get 782 approximately because we have rounded it off here. So that's another way we can easily find out the percentage. That's why they called estimation in percentage. Percentage vis-a-vis fraction and decimals. Okay, let's see. Examples of percentage at par with fractions. 10% is equal to 1 by 10 fraction. That's easy. 10 by 100, which is nothing but 1 by 10. 20% 1 by 5. 20 by 100 or 21s are 25s are. Like that we can go on. We can just check. That's the same thing. There is no dimension to percentage. As a result, it is known as dimensionless number. Okay, so that's fine. Okay, next let us look at few sample questions on percentage. 20% of 30% of a number is 8. Fine. So we have the number 8, but this 8 is a result of 20% of 30% of a number. That number we do not know, x. First you do 30% of that. Okay, then you do 20% of that. So that will give you 8. So what is that number now? So x is 1. 1 into 30% will be 0.3x into 20% equals 8. So 20 into this 0, this will be how much? 0.6x. No, am I wrong? 0.3x, 0.3x into 20% would be 0.06x equals 8. 0.0 1 second, x equals 0.06. Let me just do the math using calculator. 8 divided 0.06, 133.33. Correct. That's all. So that's how we roll here, but again this would be easier using calci rather than doing mentally, okay, because you won't even get the luxury of solving it out. Okay, that's all. Next, which number is 30% less than 75? Okay, we didn't verify here. Let me just verify. 133.33 is the number. So 30% you calculate first. Let me do that. Into 30%, you will get 40. Now out of that 40%, you get 20%, which will be 8. So that is just the verification. That's all. Now, which number is 30% less than 75? So 75 minus 30%. That's all. So you'll have to do 75 into 3, which will be 150, 225. 225 means 22.5. I just mentally did that. If you want to know how, it's easy actually. 75 into 30 by 100. So point here. So therefore 7.5 into 3. So this will be 22.5. So now 75 minus 22.5. So 0.5. 4 minus 2, 2, 7 minus 2, 5, 52.5 is 30% less than 75. Again, with practice, all these things will become very easy, very quick. So practice is the only key here. Next, the sum of 12% of 28.6 and 5% of 1.75 is equal to what value? The sum of 12% of 28.6. Okay, first calculate 28.6 into 12%. Okay, add that to 1.75 into 5%. That's all. So now how do I do? I will just consider the calculator, otherwise I don't think you can do it easily. Okay, let me do without calci only. 2 6 are 12, 2 8 6 17, 2 2 are 4 plus 1 5. So 286, 2 13, 14, 3. So this will be 3.432. 12% of 28.6 is 3.432. How did I do this? Because here point, then again there is denominator of 100. So when you do that, you will get 3.432. So now this 3.432 should be added to 5% of 1.75. So 1.75 into 5 means 5 5s are 25, 5 7s are 35, 37, 5 1s are 5, 8. So that means 0.875. So 7, 10, 12, 13, 4.307. Is it correct? Oh, it's wrong. There is a mistake. I ignored 1 0 here. Okay, my mistake. 1.75 into 5%. No. So that will be 5 5 are 25, 5 7 are 37, 5 1 are 5, 8. So now 0.2 plus 100. So therefore 0.0875. 0.0875. So therefore the answer will be 5, 9, 11, 5, 3.5195. So that is the answer. Okay, so I don't think you will get these type of problems in the exam. It's practically difficult for you to solve without any working paper. They are not anyway providing you working paper or working space in the online exam, so don't expect these type of problems. I mean, it will be much easier. What I mean is, the stationery seller had some registers. He sells 40% registers and still has 420. Originally, how many registers did he have? This we can easily do using binary. Earlier I had 100, now I have already sold 40, so that's why now I have 60. That 60 is 420, what would be the 100? So cross multiply. So 100 into 420 divided by 60. 6 7s, so 700 is what I had earlier. That's it. So we had 700 registers. Out of those 700 registers, I sold 40. So 40% of 700 registers came to 700 into how much, sorry, 40 is 280. So 700 minus 280 is 420. That is what I am left with. Next, out of two numbers, 20% of the greater number is equal to 50% of the smaller. Okay, if the sum of the numbers is 140, then greater number is dash. Fine, let's do this. We do not know which two numbers are these. Fine, 20% of the greater number, okay, x into 20% is equal to y into 50%. Okay, if the sum of the numbers is 140, then the greater number is dash. But we know x plus y equals 140. Fine. Or we can also write it as y equals 140 minus x. Okay. So, because I'm just rewriting this equation like this, x into 20% would be 0.2x, no? 0.2x equals, instead of y I'll write 140 minus x, 140 minus x into 50%. So 0.2x equals 70 minus 0.5x. So therefore this will be 0.25, sorry, 0.7x. 0.2, 0.5 add 0.7x equals 70. So therefore x equals for x equals 70 by 0.7. So therefore x equals 7, again multiply both by 10, it will be 700 by 7, 100. That's all. I think it is correct. Yeah, x equals 100. Then the greater number is 100, the smaller number would be 140 minus 100 equals 40. So now that we have found out the numbers, which is 100 and 40, let us see if it actually tallies with the given problem. I'm just verifying, that's all. Confirmation. 20% of the greater number, 20% of the greater number, 20 is equal to 50% of the smaller number equals 20 again. And the sum is 100 plus 40, 140. That's all. Fine, then the last bit of chapter 7, quantitative aptitude, which is ratio and proportion. Let us look at what exactly this ratio and proportion means. See, ratio is a mathematical concept that expresses the relationship between let's say two or more quantities. It is a way of comparing the magnitude of one quantity to another. Let's say if we indicate how many times one value is contained within the another. For example, ratios can be written in different forms, such as 3:2, or maybe 3/2, or using the words 2, like 3:2, for example, 3:2, 3:2, 3/2. So now suppose, let's say you have a bag of marbles containing 5 red and 3 blue marbles. So the ratio of red to blue marbles can be expressed in this instance as 5:3, or 5/3, or 5:3. So in different forms. Okay, so the ratio tells us what? That for every 5 marbles there are 3 blue marbles. So the best example of ratio which I can think of right now would be, let's say, bonus shares. When a company issues bonus shares, what we do? We say 3:1, 1:1, this type of bonus shares. So that means in proportion to what exactly you already have, based on that the company is issuing extra shares to you as a shareholders. So see, ratios are versatile in nature and can be used in various contexts. Maybe even in cooking, a recipe might call for a ratio of 2 cups of flour to 1 cup of water. So that means we'll easily understand, okay, if it is 2:1, then I know if I put 1 cup of water, then I'll have to put 2 cup of flour. So that is where we use ratio. I mean, it's versatile, meaning it can be used anywhere as such. You can think of 1,000 different ways in which we can use ratios. When it comes to proportion, on the other hand, It's like a specific type of relationship between two ratios. We can say it is an equation that states the two ratios are equal. Proportions are usually written in the form of let's say A by B equals C by D, where A, B, C, D, they're all numbers. That means the product of the means is equal to the product of the extremes. That means if I write here A by B equals C by D, the product of the means are equal to the product of the extremes. To illustrate, we can consider a scenario, let's say, where we have two similar triangles. The ratio of the let's say the length of the corresponding sides of these triangle, let's say, is 2:3. If other pair of similar triangles has sides in the ratio of 4:6, then we say these ratios are in proportion, because we know for a fact that 2 by 3 is equal to 4 by 6. If you do the math, ratio 3 by 4 extremes, and here 2 into 6, 3 into 4 is 12, 2 into 6 is also 12. So that's when we say they are in proportion. So that is what they have given here. You can just check it out. Mean terms, extreme terms, we did that. Mean terms, extreme terms, they should be equal. Okay, again they have given the differences between ratio and proportion. If you want to look at the differences, we can think of it this way. A ratio is always a comparison between two quantities, whereas a proportion is an equation stating that two ratios are equal. That is with respect to the definition part. When it comes to the representation part, how can we look at the differences? Ratios can be represented in various ways, including with a colon, as we saw, or a fraction. But proportions are always represented as equations, wherein we look at x by y equals, let's say, a by z, something like this, where all these are numbers. And regarding the nature of ratio and proportion itself, ratio is in fact a very simple comparison and does not necessarily imply equality, whereas proportion specifically denotes equality between any two ratios. So these are few of the differences between what you can call as ratio and proportion. If at all we have to look at examples, we can think of, let's say, there is a fruit basket with let me just write down somewhere here. Okay, a fruit basket with 8 apples and let's say 4 oranges. The ratio of apples to oranges is 8:4, or 8:4, or 8 by 4. It can be written in any which way. We can in fact further simplify this as 2:1. For that means for every 1 orange, we have 2 apples. Now when it comes to the proportion, let's say there are 2 rectangles with sides in the ratio of 3:5 and 6:10. To check if these are in proportion, equality, once again, we set up the proportion 3 by 5, because these are the measurements of the sides of a rectangle. One rectangle is measuring 3 by 5, the other rectangle is 6 by 10. Now if I cross multiply, that is means into extremes, 3 into 10 equals 6 into 5, what we get is 30 equals 30, equality. Since the cross products are equal, we say the ratios are in proportion. So that is the essential difference between ratios and proportions. Now let us look at few of the sample questions given here. Let's read this. There are 63 students available in 8th class. Fine. The number of students who want to study Sanskrit and the number of students who want to study mathematics is expressed in the ratio of 5:2. Okay. Calculate the number of students who want to study Sanskrit and those who want to study mathematics. This can be easily done because we know the total of the students, which is 63 here, and the number of students who want to study Sanskrit and maths are in the proportion of 5:2. That means for every 2 people who want to take up maths, there are 5 who want to take up Sanskrit. Fine. So now we know 5 into something, okay, plus 2 into something equals 63. because 5 into what we do not know, 2 into what we do not know, but the total will anyway be 63 because it cannot exceed 63. That is the number of students which we have. So now if I further simplify this, 5x plus 2x, which will be 7x equals 63. So x will be 63 by 7, which is nothing but 9. So if I substitute 9 for x, then it will be 5 into 9 plus 2 into 9 equals 63. So that is 45 students would like to take up Sanskrit and 18 would like to take up maths, and their total would be 63. So that is what is asked here. Let's move on. R&S started an electronics shop and decided to divide the profit between them in the ratio of 7:5. Fine. The total profit of the firm is 12,000 by the end of the financial year. What will be the individual profit share? This is again easily done. I'm sure you would have done all these type of problems in partnership in 12th standard. So 12,000 is what we have, and they want to divide in the ratio of 7:5. So what we can do is we can total these two, 7 and 5. 7 and 5 we know is 12. So what I will write is 7 by 12. Okay, because that will be R's share, and same 12,000 into 5 by 12 will be S share. So 12 anyway gets cancelled. So 1,000 here. So 1,000 into 7 will be 7,000. Again the same thing, it will be 5,000. So the answer in this case would be 7,000 and 5,000, which is the profit between R and S. Let's move further. If Abhishek travels a distance of 25 kilometers in 5 hours, okay, this is about distance, okay, how much distance can he travel in the time of 8 hours? So this is a very simple cross multiplication, nothing much. So you don't even have to think of this as proportion also. In 5 hours, he is able to travel 25 kilometers. In 8 hours, how many kilometers will he be traveling? That's all, simple cross multiplication. 8 into 25 by 5. So we know 5 5s is 25, 5 8s are 40. So he will be able to travel 40 kilometers. You don't have to do all this. Simple cross multiplication will suffice. Calculate the numbers whose sum is 88 and they are written in the ratio of 4:4. This is interesting. So 4:4 is what the ratio of those two numbers. Those two numbers could be x plus y. Okay, that will be 88. But the ratio is 4:4 or even 1:1. So now 4x plus 4 x, we will have to take x only because otherwise there will be too many variables, equals 88. So 8x equals 88, x will be 11. So now the numbers would be 11 into 4, which will be 44:44 or 1:1. As I said, 4:4 is nothing but 1:1 only.
Let's try to understand what is a square root and different types of square roots, which is part of the syllabus. Now, what is a square root? The square root of a number is nothing but a value that, when it is multiplied by itself, gives the original number. For instance, the square root of 9 is 3 because 3 by 3 is nothing but 9. So now, in case of 3 by 3 into equals 9, that is in fact a perfect square. Why it's called a perfect square? Because it's a number that is the result of squaring an integer. What is an integer? We have already seen during the introductory lesson, integer is nothing but a whole number. For instance, even 16 is a perfect square because it is nothing but 4 by 4. Then what is the imperfect square? Of course, if you understand what is perfect square, you can easily understand what is imperfect square. That which is not a perfect square. Meaning, it is not an integer multiplied with the same integer. Instead, it is a number with decimals or fractions. Okay. For example, if I think of 20. Now, square root of 20 is obviously not a perfect square because any integer multiplied by itself will not result in 20. In fact, 4 by 4 will result in 16, whereas next number 5 by 5 will result in 25. So that square root of 20 lies between 4 and 5, and in fact it is 4.47. so when you multiply 4.47 by 4.47, you will actually get 20 as the result. So that is the thing.
We can understand this with the help of example. Imagine you have a magic number like, let's say, 9. Now the square root of this number is like finding another number that when you multiply it by itself, it gives you this magic number of 9. So now for 9, the square root is 3, because another number which is multiplied by itself will give us 9. So now how to find out the square root? This again is slightly difficult because mostly it is guesswork. We can use all these methods, but from the point of view of exam, we can't do any of those because it involves a lot of calculations, and I don't think you'll be able to do that without a working paper, without using a calculator. Okay, so now one of those is estimation. As I said, for example, if they ask you to calculate square root of 55, then what we will do is we'll look at the nearest number which is a perfect square root. For example, 49. We know the square root of 49 is 7. Now this is greater than 7. So then we look at the next number, which is 8. 8 into 8 would be 64. This is somewhat between 49 and 64. So maybe it is hovering around 7.5. Maybe we can in fact check it out actually. 55 square root, no? 7.4. So this is one way of trying to find out. Then there are other ways also. For example, long division is there. So that is another way of finding out the square root. Then there is prime factorization method. We pair up the prime factors in 2's. For example, let me just take one more example. Let's take 36. Okay, so now take one factor from each pair and multiply them. First you'll have to think of something. For example, let's say 2 into 2 and 3 into 3. So pair up 2's and 3's, because we know 2 into 2 into 3 into 3 is nothing but 36. So now if I take 1 and 1 here, 2 into 3, you will get 6. So that is the square root of 36. Again, it's easier to do it for small numbers, but when we think of bigger numbers, then it will be slightly difficult. So that's why, as I said, from the point of view of exam, this is not such an important topic. You can just have a look at it once and just understand what it is and then be done with it. Of course, when you think of square roots, there are different types of square roots also. Positive square root, negative square root, real square root. Positive would be just like this. 3 is a positive square root of 9. Negative square root would be minus 9 square root, then it would be minus 3. So where is that? Minus 3. Then real square root, for example, 16. Real square root, where the square root of a number results in a real number. So that is what it is. Imaginary square root, where square root of a negative number results in an imaginary number. It is called imaginary square root. For example, square root of minus 9. So this is difficult to arrive because then we can only think of 3i, where I is the imaginary unit which is multiplied by 3. Rational square root is something which results in a rational number. For example, square root of 25, it results in a rational number 5. Whereas if you look at square root of 2, it won't result in a rational number, it will be irrational square root.
Now let us look at the different methods. The first method is as mentioned here, square root by repeated subtraction. Now how is that even possible? Let me create a new page here. So now in this method, it's in fact very simple. This is a method to find the square root of a number by subtracting a sequence of odd numbers. So what we do is we simply keep on subtracting odd numbers until we reach 0. For example, let us take this example itself, 16. Now we have to find out the square root of 16. So now what is that number which you have to subtract first? We said we'll subtract series of odd numbers, right? So the first odd number would obviously be 1. So when you do that, you will end up with 15. So then minus 3, because that would be the next odd number. Okay, So then that will be 12. So now 12 minus 5, because that is the next number, that is next odd number after 3. So that will be 7. So 7 then minus 7, which will result in 0. So now what all did we subtract to reach 0? We subtracted 1, then we subtracted 3, then we subtracted 5, then we subtracted 7. So how many times did we subtract now? 1, 3, 5, 7. We subtracted 4 times. So therefore the square root of 16 would be 4. So of course 16 is a very small number, so therefore we don't have to worry too much about it. But imagine if it's a long number. I mean, imagine if it's a what do you call a big number. So then the process would be very long. So that's one of the disadvantages, I would say, of this method, which is the square root by repeated subtraction. So now let us look at the next method, which is the prime factorization. Let's start with the example itself, long division number. Unless you look at the example, you won't understand. So we have to start with the leftmost number. So now if you look at the leftmost number, which is nothing but 2, now find the largest integer whose square is less than or equal to this part. So the largest integer, that is a whole number, whose square or less, whose square is less than or equal to this number would be 1. Okay, so now 1 into 1 we know is nothing but 1 itself. So now write that 1, subtract 1 from 2, you will get 1, then bring down these two numbers, 25. Now double this quotient. Okay, so double means it will become 2. Now we have to, what we have to do is find the next digit, that is x. We do not know which it is. This is that. Okay, so now we have 2 here. Now what we have to do is multiply some number, okay, which we do not know yet, 5 times, or let's say let's think of 0 itself. 20 into 5, how much is that? 20 into 5 is 100. Okay, can we try something else instead of 20, which is closest to 125? Why can't we try 25 itself? Okay, so because it should be less than or equal to 125. If we can find something which is equal to 125, well and good. So 24 into 5, it won't be same as 125. So we'll try 25 into 5, because we know 25 into 5 is 125. So now it is perfectly divisible. So now that means what? 15 is the answer here. Of course, this is a slightly complicated method, I would say, but still this is one of those methods which is mentioned as a method to find out the square root. So that's the thing. Okay, then we have few properties of square root which we have already seen. I don't want to get into that. It's something which is obvious. Just go through that. Now let us look at one last topic related to square root, which is negative square root. So now what is this negative square root? Let us try to understand easily. We know that square root of a positive number is another number that when multiplied by itself gives you the original number. For example, 4 by 4. 4 times 4, 16. Now things get a bit different with negative numbers actually. A negative number doesn't have a real square root, because any number, whether it is positive or negative, when it is squared will always be positive. No? For example, 4 times 4 is 16. Minus 4 times is also 16. So you can't square a number and get a negative result. So that is the thing. So to deal with square roots of negative numbers, we'll have to use a concept called imaginary numbers. So these are denoted by, let's say, I. So square root of a negative number, when you look at, for example, minus 1. Now how to find out the square root of minus 1? So So we'll have to think of some imaginary number. So only then we can try to break it into parts and then find out the square root of that, because no, what is that, squaring of any number will result in -1. So that's why we add one imaginary unit called I. Okay. For example, square root of 14, sorry, square root of 16 we know is 4. What about square root of -16? So then we'll have to add 4i, because I is the imaginary number, so we'll say 4i is the square root. Of course there is no I as such because we cannot define I, but that is the closest we can come to identifying square root of a negative number. So that's about it. We have few questions here, easy enough questions. So in the exam, of course, you won't get these type of theoretical concepts. What you will get is some easy enough questions which can be answered using mental ability. You don't even need calci. So at least that's what the institute claims, whether or not it is true. Let us move on to the next topic, which is the average. Now this is an interesting topic, I would say, because this is something which you would have already studied in high school, or high school or primary also. So now what is this average? Okay, there are different ways in to find out average. The most common way would be to sum everything and divide it by number of items. So which is in fact nothing but the arithmetic mean. That is the first average which we will look into. So now what is the definition of arithmetic mean? It is what most people think of as average. You find it by adding up all the numbers and dividing by the count of numbers. For example, 4, 8 and 10. So if I look at 4, 8 and 10, let me just move to the next page. So 4, 8 and 10, these are the three numbers. So if I have to find out the average, all I have to do is add 4 plus 8 plus 10. So once I do this, 4 plus 8, 12 plus 10, 22. So 22 divided by 3. So when I do this, I'll get 7 point something. 4, 7, 3, 7 are 21. So 1 would be left, then 0.0, so 3 something. So because 3 3 is 9. So it will be recurring obviously. 7.3333, something like this. This is nothing but arithmetic mean. Okay. So then comes the geometric mean. Now what is this geometric mean? It is found out by multiplying all the numbers together and then taking the nth root of the count of the numbers. For example, if you have let's say 3, 4 and 5. So how to find out? Okay, let's take the same examples actually. 4, 8 and 10. So if I have to find out the geometric mean, I cannot add, but instead I will have to multiply now. 4 8s are 32, 32 into 10 is nothing but 320. So then square. Which square? Now how many items are there? 3 items. So that is nothing but cube root. Since there are 3 numbers, we'll take the cube root. If there are 4 numbers, 4th square, 5 number, 5th square, 2 numbers, just square. So that would result in what is that? The geometric mean. Of course, without using calci, it's very difficult to do. All you have to do is just understand the concepts. You won't be asked problems related to it. Then comes the last part, which is nothing but harmonic mean. So it is nothing but the reciprocal of the average of the reciprocals of the numbers. That's all. For example, 4, 8 and 10. So now first we have to find out the reciprocals. 4, 8 and 10. We have to find out the harmonic mean. That means we'll have to first identify reciprocals. So that means 1 by 4, 1 by 8 and 1 by 10. So how much is each of this? 1 by 4 we know is nothing but 0.25. So 1 by 8 is, that is also easy, 100 by 8 to 12.5, no? Yeah. So 0.125. Then last one would be 0.1. I have just taken the reciprocals of these numbers. So when I do that, I have got this. So then add all the three. Okay, 0.25 plus 0.125 plus 0.1. So 0.125 plus 0.1. So this will be 57.475. So now this is something which we have got. Okay. So divide the count of this numbers, that is 0.475, by the sum of the reciprocals of the numbers. So So if I have to consider that, let me just confirm. If I have to divide this, yeah, that is fine. I have considered that is also fine. If I have to consider 0.45, that is fine. So how many numbers are there? Yeah, sorry, I forgot one last step. That is, how many numbers are there? We have 1, 2 and 3 numbers. If you have 3 numbers, then 3 divided by sum of the reciprocals, which is 0.475. So when I do this, I'll get the actual answer, 6 divided by 0.475, which is nothing but, sorry, 3 divided by 0.475. So what did I do? 6, no, 3 divided by 0.475. So it should be 6.3157, whatever. That is the actual answer in this case. So yeah, that's the thing. So now, if at all we have to understand what is the use of all these means, or what is this. See, when you want just the average and all the numbers are equally important, then the most common method to find out the average would be arithmetic mean. Then when to use geometric mean. So when you are dealing with something where the rates of growth or when the numbers are multiplied together, so then it is best to use this. There is rates of growth. Okay, it's going like this. Then better use geometric mean. Usually used in finance and sometimes even in biology. Then harmonic mean. So this you can use when you're dealing with, let's say, rates or ratios, speeds. So if you want to average out the rates, then you can use harmonic mean. So again, we are not going in detail over all this. So what we have just done is look at few concepts related to averages, and yeah, that's about it. Of course, there are a few problems here, so these are easy enough to understand, so I don't want to get into that, because see, average age of the boys in the team, so 1 2 3 4 5 6 7 8 9, there are 9 items, add all and divide by 9. That's the thing. So that's about it. Let's move on to the next topic, which is interest. So here we have a very interesting topic. This is something which is related to finance, so it would obviously be of some interest to you. So that is interest is what you earn or pay for borrowing or saving money. In fact, there are two main types of interest: simple interest and the compound interest. So now, what is simple interest? It is nothing but the interest which is calculated only on the original amount of the money, that is called the principal. It doesn't change over time at all. See, that's why it's called simple interest. If I have to drop a page, simple interest is nothing but PTR by 100. So now, what is this PTR by 100? This is nothing but principal, time and rate. So whatever is this, based on that we can easily identify. For example, let's say 100 is the principal. That means you will save 100 this year. And let's assume for a second that you will get 5% returns on that. And this you will save it for 3 years. If I do this, what would be the interest after 3 years? All I have to do is multiply P into T into R. That is 100 into 3 into 5. Since 5 is percent, I'll divide by 100, or you can directly write this as 0.05. So 300 into 5 by 100. So 100 and 100 goes here. So it is nothing but 15 rupees. So 15 rupees is simple interest which you have earned on investing 100 rupees for a period of 3 years. That is nothing but simple interest. Now, how is compound interest different from this? That would be interesting. Now, in case of compound interest, the definition is very simple. It is the interest on interest. Or in other words, compound interest is the interest which is calculated on the principal amount. Not only that, and also on top of the interest that has been added to it, that is the principal amount, over time. That means, oh sorry about this. Yeah. So that means what? You earn interest on your interest, which makes your money grow faster. For example, let us say 100 is the amount which we invested for 3 years at 5%, we got 15 rupees. So here what happens, every year whatever interest we get, that is 5 rupees, remains as it is. We won't get interest on that interest. Whereas here in this case, every year we are earning 5 rupees. Now 5% on 100 would be 5. So that also will fetch us interest. So that means the formula will be slightly different here. So they say amount is nothing but principal into 1 plus r, rate of interest, by n into t. A is nothing but the amount accumulated after n number of years. N could be anything, let's say 5, 10, 3, 4, whatever. P is nothing but the initial investment. R is the rate of interest. And n here is the small, the number of times it is getting compounded. Usually, let's say it's compounded every year. Okay. So, and this is nothing but the time in years. Let's say we have invested 100 and we are getting the same 5% for the same number of years, which is 3, and it is compounded annually. So in that case, amount would be 100 into 1 plus r, which is 0.05 divided by n. N in this case would be how much? Since it is getting compounded only once, I'll write 1 here. 1 into 3 years. So when you do the math, it will be 100 into 1.05, 3 times. So if I do that here, 1.05 into 1.05 into 1.05, that will be 1.15 something into 100, you will get 115.76. See, we are getting extra 76 paise just by investing 100 rupees. Same 100 rupees. In simple interest, we only got 15 rupees, whereas here we are getting 76 paise extra. So that is the advantage of compound. In fact, compound interest works like magic, especially if you are saving for a longer period of time. That's why they say start saving early, so that the effect of compounding will help you in building a huge corpus. Okay, so imagine if this figure was like 1 lakh, 10 lakhs, then imagine the interest being 8%, and every year on that interest you are still getting interest. So that is the thing. Of course, on this also we can solve 1 or 2 problems just to see. Let's say principal is 200. We are investing at the rate of 6%, and number of times it is getting compounded in a year is only once, and it gets compounded for 4 years. In this case, again we'll have to use the same formula. A equals principal, which is 200 in this case, into 1 plus r, which is 0.06, because 6% is nothing but 6 by 100, divided by n, number of times it is getting compounded per year only once, into 1, which is 4 year, because it's being saved for 4 years. So here also you'll have to do the same thing. 200 into 1.06 4 times. So when you do 1.06 4 times, 1.06 into 1.06 into 1.06 into 1.06, you will get 1.26 something into 200. It will be 252.495. We can make it 252.5. That is the thing. If it was simple interest, then it would be, let's look at that also. 200 into 6 by 100 into 4. So 2448. So that would be plus 200, 248. See, since it is getting compounded, we are getting extra here, 4.5 rupees. Whereas if it was only simple interest, would have got only 248. So that is the effect of compounding. So that's the thing about simple and compound interest. Let's move on to the last topic here, which is nothing but profit and loss. Again, this is something which you would have studied in +2 if you are coming from commerce background. So these are the key concepts in any business. Knowing how to calculate them helps you understand if you are making profit or losing money, that is incurring loss. It is important to keep track of what you earn and what you spend. So let us look at few of the key terms and their meanings. We don't have to refer to the textbook here, but just in case. Okay, it's a small concept. So let's say you buy something you buy a piece of land for 1,20,000. You held it for 6 months, and immediately after 6 months the price increased to 1,50,000. Now you made a profit of 30,000. You bought it for 1,20,000, you sold it for 150. So what is this then? It is nothing but profit. I say profit of 30,000. So profit is what you get by selling something for more than it cost you to buy or even make it. So if I had to put it in a formula, profit is nothing but selling price minus the cost price. So selling price in my case, that is piece of land, 150 minus cost price 120, so 30,000 is the profit. Whereas if it was the other way around, let's say you buy a laptop, because in case of land it will usually appreciate, whereas in case of electronic items it gets depreciated very soon. If you buy a laptop for, let's say, 50,000 and you sold it after 1 year for 35,000, then you're losing out 15,000, because you bought it for 30, so 50, but you are selling it for 35,000 for a loss of 15,000. Of course, we are not considering depreciation here. We will not bother about that for now. But if it has to be without considering depreciation, this is what it is. Okay. So now, what is this cost price? That is nothing but the amount which you pay to buy or make something, because it's not necessarily every time you buy. Sometimes you make also. Imagine you are into manufacturing. So if you have to think of examples, let's say you are TVS Limited. So what does TVS Limited do? It is into automobiles. It buys raw materials, then it processes them using labor and various administrative costs, and then sells them at some price. So sum total of all that would be the cost, labor, administration, etc., overheads, all those things. And selling price is nothing but the price at which they sell their vehicles to the dealers. So selling price minus cost obviously would result in profit. It is when you are making something. If you are buying something, then it's easy, because all you have to consider is just the purchase price and maybe some kind of overheads. Maybe let's say you buy air conditioner for 20,000 and maybe paid 1,500 for transportation, and let's say there is some installation also. So now all this put together would be your cost. See, that is something which you have to understand. 20,000 is my actual price, 1,500 is my shipping, and 2,000 I paid for the installation. 20 plus 1.5 plus 2, all put together 23,500 would be my actual cost. That means anything which you incur until you put the asset to use would be considered as the cost itself. So of course, again in cost we can think of two different costs: fixed cost and variable cost. Fixed cost is something which usually doesn't change, okay, whereas variable cost is something which varies with the amount of items you buy. For example, raw materials. Fixed cost, you can think of rent, perhaps. That would always be the same. Usually over a period of, nothing is fixed in long range, but at least for some time, in 1 year, maybe it won't change. Then what is the selling price? That is the amount which you sell the product for. It can be equal to cost price, which will not be the case usually, or it can be more than cost price, which is usually the case. If you sell it at this cost price, then it is called break-even point. I bought it for 1,000, I am selling it at 1,000. What's the point? There is no profit. So that is called break-even point. But if you are buying for 1,000 and selling for 1,200 or 500, then of course there is profit. If I buy for 1,000 and sell it for 800, then there is obviously loss. Okay. What else do we have? Okay, marked price. What is this marked price now? The price tagged on the item before any discount. Marked price, the price, list price you say, the price which is listed in the shop. So the price listed is 200 for a book, but it is sold for 150 rupees. Then what is this? 150 is nothing but the marked price. Oh, sorry, 150 is nothing but the selling price, whereas marked price would be 200. The list price of the book is 200, whereas I am selling it for 150. That means I am giving them a discount of 50 rupees. That is called discount. Okay. Profit percentage, it's easy to identify. It's nothing but profit amount divided by cost price into 100. For example, I buy something at 100 and sell it at 115. So what is the profit? 15 rupees divided by cost into 100, which is nothing but 15%. That is the profit percentage. Again, loss percent, it's the same. Instead of profit, we simply replace it with loss, and that would be the thing. Of course, they are given few examples. Have a look at it, very simple ones. There are a few sample questions, not very important. It's all basic arithmetic. You can easily understand this. Nothing much to do as such here. That's about it. The syllabus for CSETD quantitative aptitude. It's very basic, I would say. It's high school level mostly. This is mostly to brush up your understanding of basic math more than anything else. So if you are already well versed with these topics, you have to just glance through all these things and you should be able to score out of 4 in this. All the best.
Now we come to end of quantitative aptitude. If you have watched this video till the end, excellent. If you have come this far, that means that you're really serious, and I hope this video was helpful. Vishwas sir has done a great job by showing you how this subject is not as difficult as you think. If you put your mind and if you basically put time and effort, you can pass this exam very easily, and overall in CSET you can score high marks. And if you really want to score high marks, we are here to help you. You can get in touch with us. We have a free CSET course. We have free mock exam. We have free tests. All this is on our website, excelacademy.com. So please go to our website. The link is also in the description below, and you will get everything for free. All the best for your CSET exams.